Hello, test recording. Hello, test recording. Awesome. So stream is working. Hey guys, welcome to part two of the series. So basically, who the folks who are sort of new to this, we're basically trying to build. Uh, I'll actually share this link. We're basically trying to build an AI system that can work with rocket science documents, complex documents on-prem. Most importantly than on-prem, that should work for 85,000 documents. So this is sort of the context of the sample projects you're working on. I will definitely have this linked up. I guess it's already linked up. You can check this out. And yeah, you can see the previous video, we tackled a lot. Like we built the initial document processing and we solved formulas, we solved the basic processing, and we were stuck on tables. We're still stuck on tables. I want to spend like 30 minutes right now to see if we can solve tables. I spent about 3 to 4 hours after the live stream yesterday just figuring out tables and just trying to be creative if we can do something different to process tables like this. Yeah, feel free to check out the last one. But initial context is that we're trying to build a system that can handle more than 85,000 documents of classified, unclassified, rocket science documents, aerospace, and documents which are dense with technical diagrams, formulas, mathematical equations. 1970s scan copies, and kind of one of the documents that we are currently working on right now, which trying to solve the table problem, is from 1967, which is a clean copy of a scan, but you don't get access to cells, and it's not a clean PDF. Like it's you have to work it through images, and we're trying to figure, for example, this is what we're trying to figure out, this particular table here. It's very easy if you were to use OpenAI. You can just send it to OpenAI, and like yesterday we tested it out. It accurately gave us a good representation of the entire table. It passed the entire table accurately. But we don't want to do it. We basically want to do it using an open source model, so less intelligent model, which is prone to so much of hallucination and errors, and that's how we're trying to solve it. And yeah, cool. I guess that's some decent context about what we're building. Still, you have to just go through this to get a chance of what we're doing. We accomplished a lot yesterday, and this live stream I plan to tackle table processing, images, graphs, um and yeah, and afterwards domain terminologies. So we talked about in the last video of using 18,000 domain terminologies and building a rag instead of opposed to fine tuning, because we're using Claude and OpenAI for the agent. But let's come to that. If we have the time, let's do it. And then if not, we'll probably jump to the agent and then come back to domain terminologies when we have the entire agent working. It is then where a context on domain terminologies will actually make sense. um yeah, sometimes yeah, cool. Anyway, yeah, let's get started. So, um, now just to give you some context, if you were to you watch the video just from the second part, it's totally all right. So what we're trying to do is that we solve tables. We work with a lot of PDFs over here. So this is one of the PDF, and tables like this are very easily solvable, and we've solved it as well. We use Quen right now, and it's able to accurately give us information with relevant information, gives us the like basically an accurate markdown of the entire table. So these are not complex at all, very simple, like very simple tables. But right now we're working with one of the documents. This is from oh yeah, this is from 1967. And if I scroll down, you can see this table, right? This is a continuation of a big table, but you can see it has so many intricate pieces, and you have 18 rows, and I don't know, easily 50 columns over here. And it's not a clean PDF. So I mean, you can't like the best option right now is to use a VLM, and a VLM, open source VLM, is actually hallucinating most of the time. Just for example, for this dashes, it's putting something else. Damp is coming over here to 238, or damp is going over there in 520. So it has to be accurate, right? You need to be able to accurate, like, well, how a human would do is that even a human can understand it. He'll probably use a ruler. Like what he'll do is that he'll use a ruler, and at least I would probably use a ruler. You know, keep the ruler on 81. For example, see this particular thing 81. You keep a ruler, and then where the line goes, I mean, you'll assume that those are the actual numbers, and that's what a table would do. That's mostly accurate. You just would use the ruler. But for a VLM, it's not like that. It's you just dump in the table, and it generalizes the table and gives you an output. but we don't want to do it. So yesterday I was spending a few hours and came up with a few different approaches. One and a few, like one idea that I had was using heat map, and it sort of worked very well. I'll go through that. I don't think, even if it's not successful, but it's a good try. It's a very creative try. I'll go through that. So basically what we do is that, let me expand this, let me make this big, and yeah, zoom this. And yeah, just I would just come, just think about like humans, right? What we do is that we use, for complex tables like this, we always split things up, and also we use a ruler. Like we have like a big ruler, like 15 centimeter, 20 centimeter ruler, and then keep it at 142, and then check, what is 142 connected to, right? There's only very minimum amount of gap. Now I basically wanted to recreate this with using AI, but you can't use VLMs as well. um and that's why, that basically we are going against it. So what I did was that, you can see over here you have 722, 1078. These are, don't worry about numbers, don't worry about anything. This is just pixels, and you can see 722, 722 is a pixel. That's a black pixel. If I just, zoom in, you can see this particular number. You can see a small gap. You will have, there's white space, and then you have some digits. But for an image, in a pixel level, it's actually not it's not, for a pixel, let's just assume it's a pixel. At a pixel level, it's not actually a number, it's a pixel. So what we can do is that, for this entire table, you have pixels 110, which is a pixel. What you can do is that you have white space here as well. So what we would want to do is that, we will target each gap over here. So see this gap? So this is a gap. We can assume this to be a ruler. So what we're trying to do is that we are basically trying to identify the heat map or projectile lines. You call it projectile. I just knew the word, it was projectile lines yesterday, but you can assume it to be a heat map. So the black ones will have more of a reddish sort of feel, and then the white ones will probably be in a very light color. So it's sort of like a heat map. And what we do is that, for the gaps in between, which is the whites, we try to draw a horizontal line. So what we do is that, we create brown boundaries based on it. So have created one over here. If I were to zoom in, you can see accurately how we've gone through the boundaries. So I'll show you the code in a bit, but what we're essentially trying to do, of course, it's not 100% accurate in terms of header level, but just pay attention to each column and each row. You can, we were able to highly accurately map out the separation. So if you were to go to 153, you basically could see 153 is 126, 1040, 26, 1.94, 96.6, 592, and damp or whatnot. So this basically gives you some sort of like a rule, not a rule book, but then like in engineering, right? You like, even if you see like a lot of civil engineers and etc., they use a lot of rules. They have a lot of like mappings going on. Essentially, that's what we're trying to do. We're just trying to assume VLM is actually sort of like a human being, and you just try to help it focus more, or yeah, help it out visually. So that's what we have done. We've drawn these lines. Now the second problem here is that, even though you draw the lines, like like this is also still confusing. You don't want to, you don't want to confuse the VLM even more with a lot of lines. So what I did zebra lines for it, or you can call it zebra lines, or whatever the marker lines you want to go with. So essentially what we do is that, for every odd line, for example, 722 is one single line. So we know, with the boundaries, we know the first boundary, the second boundary. So every odd or even, it depends, whatever you can do, you just make it white, and the next you make it what? You make it a different color. In this case, I'm using yellow. In this case, what happens is that you'll have odd, even, odd, even, odd, even. So if when you see for example, if you see 81, I can easily predict that 81 is actually, what the hell is it? Yeah, it's 138, 1037, 17, 166, and efficiency whatever is 97, and etc. So I can easily predict that using a zebra line, sort of like a signal, almost like a signal. Um, I hope I'm not confusing. Yes, so assuming that it's sort of like a signal that you would use or send it to the model. So the model would probably focus more, and visually it's more appealing, and visually it's more focused, right? That's essentially it for basically like drawing lines and trying to be just trying to map out the each row, but using boundaries, because you can only use like a heat map, because this is not an actual table, this is an image at the end of the day, and it will also work in images. So this is what we did, and I ran over the model. It was good. but it still hallucinated a bit. So what we did was that, because of course there's still a lot of information going on. You have 18 rows and I guess easily 50 columns. So what I did was that we basically got a screenshot. We tried to we use an VLM to understand the headers. So headers are fixed, right? Figure chamber, test, chamber diagrams, large chamber, truth diagrams, percentage cover, contract ratio, number injection elements, static to pressure. Everything is static. Nothing is changing over there. So what we do one pass one to send the entire image and come up with extract all four of the titles of the rows, right? We do it. Second, what we do is that we pass. Now you can see we had this boundaries. Can I open up the boundaries? So we have this boundaries, right? And that is how we have the zebra. So what we can do, we can get the first four elements. So not the entire thing. Now you know that we have a list of columns, like the title, sorry, the titles of the rows, those are fixed. And then what we do, we don't pass the entire thing. I'll virtually do it. We don't pass entire thing, like we don't pass all of this. What we pass is that we only pass the first four. And this would help the model be much more focused because it's only dealing with four and not 50 columns. And now because we mathematically, or maybe we can track each cell visually using boundaries, we basically can jump into the next one accurately. And I'll show you the image that we created. So this is the row, and there's definitely noise because you'll never know, like table chamber status could also be a row, like it could be in a row itself. So we try to remove the noise as well and try to accurately predict things. But yeah, you can see. So this is one image. This is, no, I don't think this is a table. Still, we pass the entire image, get the tables, and whatever, when we come across titles of a column, the second pass, we just ignore it because we already have it. So in this way, it's not going to hallucinate much. And I'm going to scroll down and you can see you have 722, 722, 722. Sorry, 720, 724. Sorry, guys, my English. And then if I scroll down, you can see even more numbers. I can scroll down. So it's going below and below, below and below. So it goes 4 by 4, 4 by 4, 4 by 4 until you get to, I think it's 216. Now this approach did work, but the thing is, you can see this initial image. This image has a lot of white spaces. Like when you when you just when you just scan and send this to an LLM, like only this part to an LLM, it's very tough for the LLM to understand what the white space is. Is it an arrow, or is it what is it, like what is it? Like, it would probably not know that. Probably GPT or Cloud could guess it, but the Quen models are crap at this. So what it does is that when there is a white space, it's actually using 66 over here and 67 over here. And what happens, the figure number becomes the test, and the test becomes the chamber diagram. Chamber diagram injectors becomes a large chamber diagram, and it goes on. So the entire flow is messed up. So what I did was that, because sorry guys, so we can use an LLM to predict how many rows the initial columns could be, and then I saved that up like this. So this is a table. So we exactly know this. So then what we do is that we take this image and we select the four and merge it. So okay, like this, exactly. So you can see over here, you have four. You would take this separately, you will be, let me visually show it. You take this separately, save it, and then you take this four, and you save it, and you merge them. When you merge them, most of the time the answers are accurate. Now, I mean most of the time, which means some of the times it is again hallucinating a lot. It's because you can't like one of the issues, or maybe a few of the issues, one of the main issues is that you'll have a lot of noise over here. This table has this table chamber status, but something else will have something else, like you'll have something X and Y, and all of this would differ, and you would not get an accurate representation of the arrows and etc. So yeah, this sort of worked 80%, like a good try. This I wanted to, I didn't want to skip this part. I wanted to still sort of mention this because I think somebody who's way more smarter could take it on from there and try to, solve that last 20% in some way. But yeah, I can quickly show you the code over here. I did mention the idea of it and etc. and then tested it up. And yeah, raise projection, and yeah, we'll actually take 0, 5. Yeah, so this is the code. What we basically do is that I think if I understand it properly, I mean, yeah, this is just drawing the zebra lines, importing from the image draw. So the boundaries are done on the pipeline. I suppose it's done on the pipeline. Yeah, process. Okay, this is another process. I'll come to this part. This was mostly an inaccurate way of doing it, but yeah, essentially what we do is that we get the boundaries, we put zebra lines up to top of it, and we just save the boundaries. If you want, you can just save it. But then, let me ask, where is the boundaries code? Yeah, projection of light. Yeah, so horizontal projection, sum of black pixels per row and sum of black pixels per column, and then you predict the white pixels in between, and then you draw a line, and that's why you get like it's not 100% accurate, but when you come to the actual table, it's sort of accurate, and that's more than enough. Of course, all this stuff will be down below. So this didn't still end up working. If I can show you the response that we the 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 response that we did get. All tables combined, not this actually. So we got like decent information, but the end it also hallucinated a bit, and um, it did hallucinate not a bit, a lot actually, and not hallucinated, but it basically missed it. For example, if you see, you have 003 303015, right? And if you go here and see, you see 00030303015 and then 30. That's totally missed. And one of the reasons um why we even face those issues is that if I show you one of the images, or the one or the chunked images over here. I want to show you the merged images. Just a minute. Okay, yeah, this merged image, right? You can see, cause and like the head when one in one case the AI actually like took the entire this particular row as an header. So 50 was actually part of the header, and then when you loop through all the tables, it basically added the 50. Now there is no way of uniquely identifying it. Of course, you have the test IDs to uniquely identify it. Not all the tables in the future might have unique identification number. uh you can try to have different unique identification number. Maybe it's not an ID, probably it's some other number or something like that, but then that's not stable, right? You want it to be stable, or you can just depend on something as an image. So what I want to do right now is just spend a little more time to work out something else, which is we were predicting this horizontally, right? That's why we were getting the issue. Like we were predicting this horizontally, you would have all of these numbers, the arrows and etc. You would definitely have a lot of problems. But if you can vertically predict it, if you can have like vertically arrange it like this, like figure number, test and everything, the model will only need to focus on this part, like 5 and okay, now there's another vertical. Now see guys, if I were to just take this vertically, right, you have 5 and 4. But if you see, only if you scan this particular table, I just now realized that you would probably know that there's 722, which is 1 2 3 4 5 6 7 8. There's actually 8 columns over there. If you were to just send it, it's just 5 and 4, and you can never predict where the fourth, like where the figure number 4 would actually lead to a test of 65. You can never predict it. Not like not it's quite tough, it's quite inaccurate. You can never predict it. I just realized that I thought I can actually do it via vertical prediction. Now the thing is, I might argue that you probably want to do it. You can probably pass the first three, but tables might differ. This is one table. You have to generalize the pattern, and it has to be a stable generalized pattern. This would take two. But what if there was like four, five, and then another four, five in the middle, and then in the middle, for example, even this part, right? Take percentage cover and etc. You are gonna have a ton of problems definitely, because you have arrows, you have no numbers NAs over there, and those are very different stuff. You can't predict it, and it's a ton of stuff to deal with. So I'm just putting it out there. If anyone want to spend more time onto it, feel free to do so. The code is also probably, when you look at the code, you probably have the code. I'll probably have this research POC codes anyway. You can probably clone it and add it up to it. But at this point of time, I don't want to waste much time to it. But these are possibilities that you can literally solve. And maybe in the future, maybe once I complete this in the next series, we can actually train a neural network to detect the table though. So what we'll do is that we'll I have to spend a lot of money. It's okay, let's spend. What we'll do is that we'll we know that this table is probably like accurately marked by GPT or Claude. We'll essentially give it, generate accurate samples of it, and then we'll try to use some sort of bounding boxes or something like a layout detection, and then we'll train a model that can actually predict sort of tables accurately. It won't be accurate. You need to train it on million, easily like thousands of tables and etc. And if I were to generate, to be honest, I don't have much capacity to even spend like thousands of dollars on like Claude and GPT. I just don't want to. Of course, it's not a choice at all. But we can't of course, you can also depend on any small models to generate data sets for this, because they're going to be inaccurate. Then no point. I think not even a model might even work. We might try to do like a model, but then we don't need to think about the model. You can easily do heat map and layout detection. If I just spend another 2 3 days, or like easily 20 30 hours on this, I'll figure it out. But I just don't want to do it now, because there's harder problems to solve. And um this is just not this is something, not a good to have. This is probably like a must to have, but not at this stage. You wouldn't want to spend a lot of time. So what I'm going to do is that I'm going to generate descriptions for this, like highly accurate descriptions, and then chunk it. And when the search does go through, we try to use the descriptions as basically like an image, just like an image, to be honest, and then bring this up. But then we pass this image to the VLM. Now, of course, because we're using OpenAI and Claude, because it understands image accurately, it can really do it well. So I'm hoping the accuracy will not be a bummer there. But if you were to work with open source models, you have all of this blockers, and you should be aware of it. That's what I wanted to say. Actually wanted to do horizontal, but I think after I figured out that there's like arrows, and you might have very different patterns of horizontal patterns, then it doesn't make sense to do it. So we'll skip it. We'll go through something else. We'll work on something else. But yeah, this is like a good, you can use boundaries, heat map, projectiles, and etc. To like, this is quite decent. You just need to take it from there. We'll probably look at this later in some point of time or something. Um, cool. I think my camera might probably hide this. I'll put this over here so you guys can see it. All right, so what I would, and like that's one of the reasons, guys. Even if you use Claude or any tools, that it's actually a supplement for you. If you were to ask it what to do, it'll actually throw up very very bad things. Like very stupid things. For example, like after this boundaries approach failed, which is something that I was brainstorming, and I did a bit of research and then tried it out, and I asked Claude to do like projectile lines, or maybe like r- give me some creative ways of doing it. And it basically gave me utter stupid thing of processing each cells. So that's probably like 2,736 requests. I guess more than 2,500 requests or something for each cell, processing each cell and using that column as a map to bypass, or maybe just use use the column to identify which cell it could be. Like 2,000 requests is actually a lot. Like you don't need to do that sort of prediction. That's a very inefficient way of doing it. So what I would say is, guys, very general. Whenever you learn this sort of agents or whatever, try to generalize patterns across different stuff. For example, if you learn graphs, if you learn heat maps, and if you learned the basics of how image lighting works, that's just a basic thing, right? And you just try to map it out how you can do it in a VLM. Like those are like creative stuff you have to come up with, and like using boundaries. Or for example, I was just looking at whether we can look at this table in a third, like we see in a third two-dimensional space, right? If we can map this out in a three-dimensional space, we can actually on one point of view try to hit some signals or lights for each pixel. So 56.1 is one group of a pixel, and we can hit one light over there, and then depending on how much further it has, like the bounce comes back, that's a 3D representation. And I could be mad trying to do that, but that might work out. So I didn't spend time on it. We're just saying if you convert this to a 3D representation, and then you try to just mimic how light works in a pixel space, and group 56 4.9 99 transition everything into one group, and then you sort of project lights from maybe from this angle, and then just figure out how long does each space take, and then use that as one number and figure out the location in between. Try to figure out it's a horizontal or a vertical, or maybe even the lights could also travel in horizontal way, but still you have to have this sort of 3D understanding. I don't want to go into that because that's not the whole goal of this. This is like 10 to 20% of mostly the tables. That's something that we should try later. So just putting it out there, we'll probably try it out later. That'll be like a code side thing to, even if it fails, I think it'll definitely fail, but yeah, it's like we'll learn a lot of good info on that. Um, all right, guys. So I think we'll see the progress. Yeah, I'll be like, be super creative and like not creative, just try random things that you'll never know because there is no rules in this space. Like with agents, VLMs, or whatever, there is no strict rules. There's nothing, there's no rule book here. We just have to create the rule book. Just be creative and just try to figure out things. And one of the reasons, for example, I was actually meddling with Llama Cloud yesterday, and I literally used 45 credits to map it out, and it still was inaccurate. like these guys have millions of dollars and they can't like 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 for example, we just solved this basic passing yesterday in like 20 minutes. Passing text is nothing, passing images, passing the entire table detection, like detecting this is a table is not an issue at all. Detecting these are images is not an issue at all. It's like baby shit. And these guys, I don't know, raise millions to build this stuff. But uh I was assuming that they would probably have they would probably have like good tech stuff, something going on here, some sort of custom passing going on here, and it literally hallucinated a lot. Like you could just see with the stable qualification, just see the stable qualification. It's 100. It's, for example, see this number 59.7, 77, 82.8. What are these numbers? This is complete this is utter crap, to be honest. 100% inaccurate. You would just like you can't do this stuff. Like you pay for a service like this, and you use like credits to use it, and this table is like completely what do you call, completely inaccurate. So if we probably design something even better even without using a boundary in VLM. So that's what I'm saying. Like just because these guys do it and it sounds nice, if you like actually check it on complex stuff, they actually fail in most of them. So there's a lot of open space, even in document processing. At least there's a lot of open space. You should definitely try it. In the morning, I was just going through LinkedIn. I got this landing AI. This was from, I guess, deep learning AI. They were releasing some content, and I wanted to try it. But the thing is, of course, I don't think this is open source. So it, like we are struggling to figure this out in an open source end. If it was Claude, we've solved it yesterday. So I didn't want to, just spend more time in it and just waste time. But I guess this could be an option. Llama Cloud you can use if you want to get like basic baby stuff, like, but my code is there in GitHub. Just clone it. You don't need to pay for Llama for what, like detecting this sort of tables is nothing. Our extraction does it better, and the tables is something that we'll probably figure out, and we'll see. And I want to solve It's interesting problems to solve. I guess that the in terms of business itself is like a huge market. If you were to solve this table, it'll probably solve a lot of other complex tables as well. Yeah, if you want to do like basic stuff, you can go through that's what, just try out different tools and see. I just wanted to take some inspiration on how they process and stuff. And I think I selected the agentic, the higher tier of using agentic to create agentic some shit. Okay, agentic plus, which is pure lies, to create this sort of markdown. I don't think they're using any agentic plus. I think agentic plus meaning like they are trying to detect um what do you call using some sort of model in between, like even parallel or something, any other model to detect paragraphs and then sort of score it. And agentic plus is probably like reasoning through and reading 2 3 documents and then trying to referencing others, referencing tables, trying to do different fact check things like that and use some sort of VLM sort of reasoning aspect to it. But I think it's probably just the same thing. You can get nearly the same results using Dockling and using my parser. So feel free to do it. And yeah, yeah. Cool. So we'll jump in. I'm gonna start working on formula detection is done. So that's done. We solved it yesterday. And we'll actually work on picture diagram. So I'll be like, so thank you. We'll actually, no, for example, we'll actually need to change it. So this has taken a lot of time. We'll make sure you remove the recent code, which is definitely inefficient. And then let's have an LLM that, oh, what can we do? I think we need to uh, we need we need the if it's complex enough, we want the LLM to say it's complex true or something like that, and then we just generate description. So what I want to do is that if the table is very complex and if the LLM has a low confidence score, if it's very confidence score, if it has a very low confidence rate of accurately extracting the info from it, the LLM should output complex equals to true or something like that. And then instead of the extracted markdown, it should actually output a very detailed descriptions with all the nuances of that specific table, which we will actually use it to chunk. Do not jump into code. Do you understand what I'm trying to say? I usually ask something like this because the LLM will just assume the LLM will actually assume I mentioned something else and it'll do something else. I usually, sort of ask like backtrack it and just ask it question. Did you understand? Then it'll probably give me a visual aspect of it, and I'll be like, no, it doesn't. No, I meant this. I meant that, and just save some time there. So first pass ask VLM to assess the table. Can you? No, we don't do any first pass. There is no need to do any first pass. It can be part of the same prompt. It just needs to come up with, like, it needs to if it's confident enough to do give an accurate representation, yes it can do. But for complex stuff with a lot of complex, if it's more than certain, if it's more than a certain level of rows and columns, and if it's very complex where details matter, then you should give only descriptions. So usually a VLM should be able to handle most of all the tables, and very complex ones is something that it should basically come out, it should basically realize it, and then it should output a deep description. Do not need any first pass. We're basically wasting tokens and API calls. You can do it in one call. Yeah, it's right. Yeah, one prompt, simple table, not simple, I would say. Even if it's a little bit, even if it's like a little more complex of a table, it's still okay, as long as it's confident enough to give an accurate 100% accurate response. If not, only you should fall back to complex too. So I mean, this could be wrong. It's still a prompt issue and there's a lot of randomness here, but we'll check it out. If it still fails, what we can do is that we can hardcore numbers on the number of rows. If you have 18 rows and, like, I don't know, 18 rows and 3 to 4 times of the number of a row, which is that you can still have 18 rows and have 4 columns, it should be simple. But if you have 18 rows and if you have 50 columns, then so probably 3 to 4 times the number of rows, if that makes sense, then that could have different threshold of complexity. And this is complex table, but we're gonna nail it. Extract simple looking table, but VLM is simple. What the shit? No. Simple looking table, the VLM should be able to do it. Complex table also, as long as the VLM could do it. So whatever the thing is, as long as the VLM realizes that it can give 100% accurate table, it should do it. Only if not, complex becomes true and you return a description. Yeah, we'll see. We'll actually see. I'm hoping that it'll probably yeah, I think it'll probably assume that's going to be it is going to be complex, and it'll probably give us a description. So we'll see. Yeah, so we're removing the single cell call. It's 2500 API calls. Most inefficient code to ever for a very simple solution like this. So we'll just remove that and have this instead. The thing is, we can always come back and like like nothing is fixed over here, so we can come back, change it, improve it, and later point in time work it. For now, I just wanted to work on most of all the documents in the number 10,000, and then accurately evaluate it, accurately do the agent, and then of course, and then you can spend whatever amount of time to make it better, polish it, or the way you want. But get the foundation right, and then you go from there. With agents, have more of a reddish sort of feel, and then the white ones will probably be in a very light color. So it's sort of like a heat map. Well, cool. Yeah, let's test it. Don't think we need Docker. We got use VENV. Okay, and details. Okay, we got a detailed description, I think. Let's see. And okay, description. The table has 15 columns, approximately 30 rows, including header row. Columns are the string. The table is defined into table chamber size, another section. Um, cool. I'm just thinking if we should have something else added to this. Probably like tags or search queries or something like that, because I'm not yet entirely sure how the user would actually prompt a search for a table. Like check this table and find me this, check this table and find me this, then it should basically. Yeah, so I think then that's the description. we need to have some sort of notes as well. Because this description, I don't know how useful this is. Like, if you wanna find something, find me something on l- chamber studies or something like that. And okay, this description, then you'll definitely find the description because you have table changes. I hope most of the time. I think I'm just thinking what other ways it could be useful for people when searching it. I know it's an agent part. You have to, tune the agent to be able to search it this way, but still, just trying to see if you can have any additional notes. Um, okay, but I would, because the thing is like this, like the table itself is most of the time has most of the needed information, and you would only needs, yeah, like in terms of context, if you don't need the first page or the second page in between of the page, between of the table, because mostly the table is quite explanatory, and like once you figure out the table, the agent could basically read the adjacent text, maybe up or down if it needs to. So we don't need to have any text. This is okay for now, I would say. Yeah, we'll just keep it as it is. So yes, now I would like to test the entire pipeline or the entire images. Sorry, not the images actually. Now I would like to try out the entire pipeline. So I would probably drop in a PDF, and it needs to extract, yeah, all the tables accurately. And for the ones that it can't, it should have complex true and in the description as well. Now what we'll do is that we'll use this complex true and then sort of chunk it back to the what do you have? Chunk it back to whom? Chunk it back in quadrant. And also I'm curious to know, does the tables or the layout tables provide any metadata, or like doctrine, does the model provide any sort of metadata? Just curious. Just check the code and let me know. Maybe reference the object of lambda. And you can, yeah, just I mean, just I'm just ranting until it does the work, but you can see 1.9 is actually not part of 774. You can see you have, it's part of 1.9 is still part of 10.7865. You can say it, but it's actually in the 774. So rather than making mistakes and just giving hallucinating and being confident enough being hallucinating, the best approach is to just show the image to the user and let him figure out, and pass it to the agent at the end of the day, and he should figure out. Because accuracy is one of the very important. We went through the personas, we went through Sandra's use case, we went through so many other juniors use case. Accuracy is very important. So we'll just initially show the image. It should be fine. I don't think it'll have a lot of metadata because we are itself trying to do layout detection, and then just process the table, right? Even though metadata, it won't be helpful. Not won't be helpful. Like there's not a big difference even with metadata. You will only need metadata for like chunks. For tables, you can just search it up. Yeah, I guess we also need to add domain 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 terminologies. This document provides page number, bounding boxes, number of rows, number of columns. Yeah, that's very inaccurate. Probably it won't be accurate. Cell row, still everything is inaccurate. I tested it, and not tested the entire metadata, but I tested the model, the docking model, and the 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 chunking itself was very inaccurate. So I think I'll suppose the column header span on all of them will be inaccurate. What we can use is the page number and BB box. Page number still, we don't even need page number because, I think we might need page number. We will say, we'll actually use page number and bounding boxes for now, nothing else. That's more than enough. Table numbers of rows, table cells, row span, like we don't need it. There's no good reason to use it. Mhm. Sure. And we'll pass in this one. Of course, we'll test it with this one, and then we'll try it simple this thing as well. Wait, isn't this part just in process? Okay, yeah, I can tell this later. I'm not sure whether we'll this cause any issues with the format options. Anyway, page number will be totally page number. We only need bounding boxes. Bounding boxes will only help page number. We can just have it. Anyway, we'll just give it a try and see. So there's 4 tables. Okay, it only found 3 tables. Yeah, we had the same issues. One is a missed table. Oh, what is it trying to do? People in PDF format, original bottom. Yeah, true, because we are turning the image, because you see it's vertical like this, and what we're trying to do is that split the image like this. So then those mounting boxes will not work, right? You have to basically do like an old, what do you call? You have to do like a skewed version of it. So instead of like this, you probably want to do it like separated. I think that's what it's trying to do. Because we are trying to do it like change a portrait to a landscape mode, because the PDF, you don't want to, it'll confuse the VLM. I think it'll probably confuse the VLM, because the data set created would be of a landscape, or will be probably visually be like a landscape, and then you have training data on top of it. So then if you were to give like a vertical table, then it might hallucinate. Not sure, but it might. So because of that, I'm just going to just turn it up as a landscape and then send it only if it's sort of portrait. If it's landscape, it's, of course, it's landscape. So it found three table. Pipeline is working. Actually, guys, I would also do one thing as well. The thing is like this. This is a worst case scenario where a table is in portrait mode, but usually when you extract tables, it could be portrait. Like a very small table could be portrait. You don't want to horizontally split it. So what I'll say is that actually don't transform the image or the BB boxes. Just keep it as it is. Don't transform or don't change the image from being portrait to landscape. Just keep it as it is. And also make sure you change the production code, which also takes into account takes into account missed tables and etc. Check the code, you'll see it. So because yesterday we worked in a way, yesterday Docklink incorrectly clarified one of the tables as being an image, a picture item, and then we converted it into a table. So we want to also account for missed tables as well. So that's what I'm saying. Let's not convert it or just pass it a turn around, because worst case scenario is just we don't, and also we only generating description. So yeah, the probability of it going wrong is very less. So yeah, I mean it's contradicting for what I did mention before, but still, I don't want the other tables to be inaccurate. So which are also like those are not descriptions, right? Those are actual tables, so that has to be very accurate. So let's see. Yeah, don't transform BB boxes for production codes missing tables, and remove image rotation. Good. I think it's modifying a lot of code. We don't need this. We just copy it up. I also want to try this table once, because we solved the formula detection as well, right? Once we solve graphs and figures, I want to try this table. Is very good table. This not a table. This one only 63, very old, but still a very good clean copy. You have images, and this is how most of the documents I think I've seen, like as far as what I've seen, 50 to 60% is like very good docs like this. So you'll be safe if you were to work on a production use case. You'll be safe because you're working with clean stuff most of the time. And I would say, and one more thing, this is from NASA, so it has a lot of metadata. Stuff are cleaned, good scanning, etc., and it's unclassified. That's why we even I can even do this, like do this sort of video. But when you work with companies information, you would never know. You wouldn't probably have any good metadata. You won't probably have I don't even think you have like proper folders, and you have relevant folders, just a mix of jam. Like not jam. You probably have to understand all the folders, all the docs, read so much even before you jump into the first line of code. So yeah, I don't know what's actually saying. So it's taking more time. Please continue. No, I want it to be in a single parser. So when I send the PDF, it should do the basic chunking that we did, but also extract tables, extract formulas, everything in a single this thing, because we solved all of them. Not a single disk, but pipelines or a flow or slash flow. Pipeline or a flow. I don't think we have one single production file, but it's okay. As long as we have one file, it's okay. Actually, I would say let's not do it. We'll actually focus on the table extraction properly. I think it was, yeah, we'll probably focus on table extraction properly. Once we figure this out, once we figure out everything, we'll merge it into one single pipeline. Don't worry about it now, because then I'm pretty sure it's gonna mess up some code, and probably I don't want to spend hours figuring out or just trying to waste my time. So we'll just solve each of them separately, and then just bring them up, bring them into one single pipeline. Mm, load PDF document. Okay, so yes, please, and we'll pass this document ID. In the meantime, I think we can work like yesterday parallelly on what is that parallelly on the two images. Okay. All right. Update the progress on the development plan MD. Just keep it as concise as possible, and then let's start to work on figures and images. Table extraction, docking, docking pages. In progress, detect images, figures, diagrams from documents, extract figure captions, and surrounding contextual text. Yes, that's what we want to do. Good, but check the code. There's actually four tables. We actually solved this. We actually solved missing tables as well. Check the code on that because there's supposed to be four tables totally, but we only got three. But we actually solved this, and we got in one of the test cases. We got all of the four tables. So make sure you check the code and update your code as well. Okay, so okay, let's see that. You should be able to figure out that's just no big. Before you create it, let me know what approach, how are you trying to do? Because what model are we going to, what model are you going to use and etc. Because I have an idea, or I want to do it in a, in a, I want to do it in a specific way. So I just want to know what you have in mind, and I can share more info. Mm. So protection has find missing tables function that takes tables mentioned as section headers like table one, but on the trigger is equal to okay, cool, yeah. Because you'll still have tables, and then we assumed, right? You'll have a table. If you can recall it, basically what we're trying to do is that some of the times the tables can be an image. This could be like the second table can actually be an image, but the thing is, you can detect this as to be an image, and this could have a section title of table, and you have the chunks. So the section header, if you see doclinks, oops, the JSON chunks are JSON. If I scroll down, you can see a lot of headings like this. And in this headings, you can, in this metadata, of course, you can see if it has any subheadings like tables, or if it's section header, if it has an actual value of section header, etc. And then you can basically, we're playing this game through metadata. So yeah, and you try to match the table over there. Usually it should work. Some of the times, for some reason, the model might, miss the table. So then that's why we even do something like that, so we can find also the missing tables. Find missing tables, and you can see item lot label, which is the label is actually in the metadata. The section header, that's title, that's subheadings, and etc. Section header, they'll actually, you'll probably catch it because this would probably be in section headers, or in any table. It's an array of metadata, so you'll have some words saying it's in a header or a table or something like that. Stop with the major section. This is okay. Let's see if it works. Hopefully it should. Okay, so yeah. No, we can actually use docklinks. No, the thing is like this approach is completely bad, because you might have a couple of diagrams or couple of images, and then you, unlike formulas, like those images can be big, and you need descriptions for each of them, and you need to have surrounding content. So, and docking is good at, it's also like, we're just trying to use what it's good at. It's also capable of, getting bounding boxes or detecting figures really well, because that's very, it's mass in value, right? You have, it's a figure. When you see a figure, it's a figure. Formulas are very hard, so this, we don't need this. It's very inefficient. So what we'll do is that, let's complete this and come back to the table one. So what I would say is that, mm, we'll use docklinks detection. We'll use docklinks figures and image detection, and we'll use the bounding boxes in order to extract that particular figure or an image, and we'll probably not send the entire page, and that, I think that's very inefficient. For each figure or an image or a picture or whatever, send text chunks, 300 chunks above and 300 chunks below, and make sure you are telling the model of that adjacent text of this is below and this is above as well, and then you share the image as well. What else would you need? Yeah, I think there's a lot of noise in these documents. This is from my past experience, guys. It dealt with a lot of noise, but we'll solve it. I just don't want to solve it now, and it'll not make sense for you. We'll hit an issue, and then I can explain why we hit the issue and how we can solve it. But it should be okay for now. Yeah, crop the image, extract it, and send. It's a very clean approach. Like you don't need to send an entire image. Uh, Find missing tables mentioned as section error, but not detected missing. Yeah, okay. Create picture extractor. Yeah, getting bounding boxes. Expand. Yeah, you can increase this expansion actually. I usually keep it at 10, 15. 0.5 is okay because image detection, layer detection is very good. The model is very good at this, so we can accurately assume it could be right, but we'll still test it. We get the bounding options or else. Yeah, seems right. I mean, nothing complicated there. So we'll test it. Content from the image, text up, text below is caption. If caption based on an image, provide clear description of whatever key elements. Do not hallucinate. Yeah, this is good. More than enough. And then this is passing the image, processing all the pictures, and formatting the pictures into markdown. Picture description says markdown. Process of the picture. Why markdown? Maybe this is just for giving us an output, I think. Yeah, just to show. We don't need markdowns. We just need to show the descriptions. Okay, but I think this probably is used to show us like a prettified output or the description on the terminal. So we just keep it no harm. Here we'll process the same image. Now we should see 4 tables. Let's see. Quinn VL, yeah, this one. Yes. I remember we actually chunked all of the tables. Oh, I'm not sure how, where does it exist really. So it has table header. No, it has table header. Maybe can you check if it's detected as something else? And also, can you see it's actually missing this specific table? I think so. And this actually it's actually portrait image. This is sort of like a landscape. This is also sort of like landscape. I'm not sure. Maybe this is why it's just assuming it'll vertically it'll probably vertically see it, right? It'll vertically see the table. Then assuming this doesn't have much columns, it's probably not a table or something. I think that could be an issue, but let's see. We don't need to capture any caption. We don't need to use any caption. We just need the bounding works images, pass it to VLM, and then get what we want. There is no need of caption. Yeah, I think so. This is basically trying to find the gap in between and check if there's something on the continued status, and that could mean that there's a model, there is a table that's being continued from the initial table. Yeah, and I can see on the logs we didn't probably solve it before, so okay, let's give it a shot and see how it goes. And assuming even if it works for normal tables where there is no continuation, and with continuation, then that's good. Continuation. Yeah, let's see. And we don't need key elements as well. We do not need key elements. Let's see figure 0. Yeah, I think it's good. Equivalence of the burner, twist ratio. Yeah, of course. Can you see here, guys? You have confidential. This is also an image. That's what I was talking about the noise. But there's a good, easy way of removing this. So don't worry about it. We'll definitely remove it before we wrap this section up. That's one noise. Let me go through. This is good. So this is a noise. We'll remove that. This is good image. Descriptions should be good. We just have to increase the padding, I think, a bit. Um, this is nice. This is very good. This is nice. Very good. Nice. Very good. Good. I think now the thing is like this, because we are anyway sending above 300 chunks for and below 300 chunks, right? Even though this is cut off, the text will be there for the LLM, for the VLLM, which means that even though in a bad case you end up with the graph only and not with this, you'll still end up the LLM will have will have info on variation after afterburner inlet total pressure and all of this, whatever the info is. So these are nice. This is the images is great. Like that's it. Like layout detection mainly for figures, it's awesome. And you can see all of these are nice. So we'll remove this stuff. Yeah, cool. So I think again we only see two tables, three tables. So show me the JSON file. Show show me the JSON file. Yeah, this one. Cool, guys. And these are nice. Where's the nice? What the hell? Oh no, these are okay. These are image path, and then I saw the images. I confirmed it. Before and after text is also all right, so it's okay. Let's see what it returns back. I don't think it saved it into a PDF. Yeah, I just printed the results. I'm sure why this is taking some time. Page 10. Why is it taking too much time? What's happening in the background? Oh yeah, it's generating. Also, does the VLM generate descriptions if it's complex? If not, the all four should have been, each request should have been very low. Like the output time would have been very low. Test it for one image. Oh, first of all, I would like to see. I would like to do two tests. One is to see all four table images, just to make sure that we got all four of them right and nothing is duplicated. Second of all, I need to run this for just one image. The first, whatever detection, let's just use the detection code and only for the first image, and I want to see what description it generates. And prompt the model to say make it make sure it's maximum 250 words. Okay, 40 pictures are saved successfully. Let's open the MD. Display shows NASA, NCAA. This is right. So it was NCAA, and I'll see it's actually figure 39. You actually have 39 figures. So you can be in a math level, it should be right. And these are nice. These are nice. For example, let's take figure 5. It should probably be something irrelevant. Image shows large irregular black shape with rough fragmented lower edge, more solid upper proportion, which is true. And dot matrix text and all of that. Yeah, so black spot, again black spot, I guess. Black spot, the first image would actually come in on Uh, okay, page figure 21. So let's go down for figure 21. And you can see this is black box, and here you see this is semantic diagram of an afterburner with variable in combustion chamber. It shows the longitudinal cross section of afterburner, including components such as vortex generators, spray bar location, frame holders, cooling hand, etc. You can see the key elements. Afterburner with variable, the vortex generator. Okay, again, maybe key elements also is also good. We'll just keep it as it is. Very good, I would say. Very good when we search stuff, because we're gonna chunk both of them into a single text, and we probably can bring this up because yeah, I think it'll be hopefully useful. Now I wanna mm, before you mark this as done, I want to remove a lot of noise. So if you look at these tables, they have a lot of confidential marks, they have a lot of stamps, they have a lot of logos which are non-technical and which are not relevant for our chunking. So basically what we need to do is that we need the LLM to decide whether it's technical or whether it's a graph, or whether it's not a graph, but then whether it's we can have, we don't want to hard code the LLM to work with only these amounts of like let it predict whether it's a graph or a picture or something like that. Not like that. Let it predict what it is actually is. It can see the image and it can predict it. And for noise and for irrelevant non-technical stuff, the value the value should be irrelevant, and it should, yeah, the value should be irrelevant, and it should be something like non-useful or document artifact or something like that, which is document artifact which is not useful, sort of thing. Do you understand what I'm trying to say? Do not code. Okay, so this is a custom test. We'll run it. Yeah, current problem, the extractor figures have a lot of noise, declarative scams, confidential, NASA logos, page numbers, form fulls. These are automatic outfit that are useful technical relevance. Don't hard code figures will determine predict what it sees. Add a classification for non-technical. I would say add a classification for everything. You know, let it classify it's a graph, it's whatever. Like let it clarify that. That'll be probably useful for our chunking. But if it's non-technical and if it's a lot of if it's definitely noise, classify it as document artifact. Or maybe what we can do, and then return return something, return irrelevant as false or true. Makes sense. My next question. Okay, so first image, table 1 experimental data. Second image, A296, I can confirm that's right. Sir 1552. Last one, 34. That's correct. Yeah, nice. It's working. It's working for continued tables, 34. And yeah, the description did for 250. Yeah, okay, so 250 is more than enough, I think. 250 words is more than enough. Good. Now update the code to handle this. Sorry. Now good, process all the four with the limit. And no, actually, I guess, yeah. Yeah, so yes, perfect. Figure type, let below classify graph, semantics, flow charts, photo, diagram, document artifact, or etc. Relevant bool, technical figure useful for graph, semantic, false, document artifacts, nice, stamps, logos, output format like descriptions. Okay, cool. Yeah. I think it's processing the PDF. Let's kill the process. I actually want you to process the PDF now, like directly the PDF. And I hope all of your recent test changes, like the description, or the complex true, everything is available in the current code. Figure types, elements. No, we can still have key elements. It will be very useful. So it'll be like, no, we can still have figure elements. Brief patterns, JSON tables. All right. Cool. Full extraction in 50 seconds was in 4 minutes. And we have all data over here. For first table is approximately 30 rows, 50 columns. Key columns include figure number. Good. Cool. We can make it better, but I think this is very good. So we sort of solve tables, but just to be safe, I also want to process this because this table is different. What if there's a different table like this? We need to be able to accurately access this. So there's how much? 1, 2, 3, 4, 5, 6, 7, 7, 8 tables, I think. We'll process this just for safety. I want to process this. Want to process this. Okay. On this. On this. On this. Okay, we'll run the classification. Okay, we'll run the classification. Okay, we'll run the classification. Okay. This will take a little bit of more time, I think, because it has 8 to 9 tables, I think. I think so. 8, maybe less. Oh shit, it's 2 out of 7. Oh, maybe it's because it's extracting the tables, I think. Oh, that's so much time to do. Okay, well, maybe it's an internet issue because both of this is like taking time. Damn, this is so slow. I wish I can actually run the model. In fact, I'll see and rent the pod. Yeah, I didn't expect it. Well, let's see. Even if it's $5, we could probably use it. I think it'll be $5. Odds. So we're using the 10 32B VL gram model, I think. This is what we, yeah. How much VRAM do I need to run this model on 8-bit quantization? So this, I think, minimum we would need 30 GB, maybe. I think 30 GB, 32 billion one, right? To it on 8-bit maybe 30 GB, maybe even less. I don't know, but still we'll use some. We'll use 5090. If it's less than 32, not now when we only do processing because I don't think I can. I don't want to pay for anything now. Yeah, so bare minimum to load the unconscious 36 to 40 GB and 8K int 8. Yeah, guys, so that won't work out. We at least need two 5090s. And yeah, I think we can go with A40. That's 40 cents. That's also 40 GB RAM. I think it could accommodate 40 GB. Inference is also, I think it should be okay. It's not a huge complex model, not a high weight model. Because the APIs are very slow. Um, okay, yeah, it's right. 8 count, yeah. Extracted to margin, what complex JSON truncated maximum. Actually, I don't know why it's using JSON in the first place. If it, yeah, it's yeah, the markdown is JSON. Yeah, we just have to increase the output. Should be okay. Yeah, actually make it make make make, make it 10,000. Make it 10,000. Yeah, some of the tables can be, you might have a lot of tokens. We can Because you also need an image, no? That's also, it will consume as being a token depending on the resolution you're sending. Yeah, so what I'll do, not now, but later, we'll rent, I'll put some credits, $25, and then we can actually rent the pod like A40, and then we'll try to also learn how to do parallel, how do you process like hundreds of docs in a, uh like in a limited scale. Like you only have a limited number of cores, you only have limited number of VRAM, we only have limited number of GPU, but still if you want to parallelly process them and run it overnight, how would you actually do it? So we'll actually look into that. There's a lot of cool concepts you can like there's a lot of efficiency boost you'll get with so many different ways of tokenization, like tokenizing, and also just not tokenizing but also in quantitization. Like yeah, so many efficiencies. So we'll just look into it. I don't want to go much into detail. I just need to get this inference done first, and then I want to show you how a base deployment on a GPU would look like, and after you optimize the GPU for that specific model, or maybe with all the drivers and etc., how will it actually perform. And then yeah, we'll just run like 20 something, 20 process 20 in a given moment or something like that, and we'll manage context lens and etc. That'll be in the final, maybe if I have time that'll be in the final video, not now. And we'll try this, and it has, the processing is done. Check this, and you can see guys, I think the actual image, the figure or the figure image starts from 15 of 16, I think. Just 21, sorry, yeah. So until 20 it's actually false, and then 21 you have a proper image. So let's go back here, and all of them should be false and 21 should be true. So if I were to search true, 21 should be true. If it's right, yeah, so it's true, so it's accurate enough, I can confirm that, because everything else on top is actually false. So I'm searching for true, and you see 21 is actually true, which is what makes sense. Key elements, description, type is semantic, graphs relocation mark, classification stamp. Yeah, cool then. So there's only a few relevant documents, and yeah, that's good. It actually works then. That is also solved. One last thing, if this table is done, you just mark it as done, move to chunking, and yeah, move to chunking, and it, that's also very simple. It's using directly from docklink, so we just use it, and then save it to quadrant, and we can jump into the agent part. Sorry, guys. Sorry. Mm, mm, yeah. Yeah, so we basically, yeah, we'll see a summary a bit later. This fourth table is being processed. Let's give it a minute. Okay, mark the progress in the development plan. Figures are also working, I think. And yeah, so if you see it, like it's not like like not that complex at all. Like we're nearly done with the chunking part. So let's see. So fourth one is taking some time. I think fourth table is a bit. Yes, this is the fourth. Maybe this is what. This is the fourth table. I don't know why it's taking much of a time. Seems to be very simple tables. Okay, so I think it's done. No, it's an error actually. I think it's timing out. It's actually timing. I would like, can we batch process it? So what I'm going to do, I'm going to run this code so I can see the logs actually, because what's really happening is I miss to see the logs and it might assume some runs. I wish to run it. Give me the proper code. Oh, it's in research base. And total page is 8. You can see as well. One is 8 bits. Okay, this is 2, 3, 4. Okay, extract rate. That's good then. Because we batched it out, right? So then this is very quick. Yeah. First one, what we'll do is that we'll actually convert this into total solids. So I think this is this, not this one. But I think the missed one is at the end. Yeah, it's fine. We'll figure out the order in a bit. Right. Format this accurately. I mean, format this accurately. Okay. No, this is because it's missed. This is actually in the end. Format the tables accurately. Image. Oh shit. Format the table accurately. Tables accurately. Okay, the thing is like this. So even though I mean this is in this format, right? But Claude probably gave this in the first place because the page number I was like check it, do it accurately, right? And the page number is 15, so it'll probably put sort it by page number. But in actual JSON, it is actually in the very bottom. Okay, so you can see summary of metallized propellant property considerations, and you can see this accurate. And scroll down, table 2, you have aluminum gel propellant compositions by weight percentage. This is also correct. I'm not sure if it's generating notes. I don't think it's generating notes. Yeah, that's easy. Table 3, that's all. Okay, table 3 is not accurate. I think it missed this table. No, I think it didn't miss table 3. Table 4 is also missed. It's very inaccurate, guys. Again, we're hitting a bump. What I'll do is I'll give to Claude. Okay, maybe the JSON. Oh shit, I didn't scroll down. That's the thing. Oh, okay, it pulled it off. Okay, okay. It's not in order, so it's not. I don't think the tables are in order. So let's verify this initially. What we'll do is that no, just come back. So this is okay. There's table 3, 400 series, right? We'll see if we have the 400 series. 400 series, 400 series. Well, compositions, table 3. We'll just verify the JSON itself, guys. So that's total solids. Let's say we have total solids. Sensitive. To 455. Formulations. No, give me the JSON. No, no, give me the JSON as it is formatted. Do not format it based on anything. Just output the JSON in markdown format. That's it. No, in markdown format, as in a table, but then in the same order, the same markdown. Okay, that's what. Yeah, I think it's mostly right. The thing is, this created like fake text and titles. That's where I got confused. You have 942 gel separation F. It's okay. Sin 42 gel, same thing. Separation F. 0.285. Correct. 200 mm. This is also right. This is also right. Yeah, that's good. Yeah, I was confused. This looks good. Where is the title? But the markdowns just give the tables, like it doesn't give the titles, like it needs to convert that, like it needs to give all information in a table, right? It doesn't have any Like it's just bluntly, if you were to check it, it's just bluntly the tables. It doesn't have the heading. It doesn't have anything. Do you understand what I'm trying to say? So because it's like, see, it's table five. What if you scroll up, you have table 3, and then you have 400 series aluminum, whatever. This is like really good text, but we just got the formulation number, state, persistence, solid, or whatever. If you scroll down, you can see that. But this will not make sense because we need to have the heading as well. Then only the search would happen fast, or it's useful for the search, or essentially even for us to visualize. So we need to fix that. Yeah. So I also think, mm, let's make this, not make this change. Date. Oh, it's fine. We'll actually make this change. It's fine. Title here now. I also want to add the point is that the images, I just checked one of the images. The title is actually being cut off. So what we can do is that, and you probably should increase the padding, meaning you should capture, you like, I'm just curious, why are you cropping it and how accurately are you cropping it? Do you think cropping here makes sense? Because if you don't crop it, like, you probably have the context. I just want to, so maybe we'll just try, just for a test, let's quickly try, um just, I don't know, 2 or 3 images. We'll have them cropped through and then not being cropped as being false or something like that. In cropped, yeah, just I want to see whether it's cropped and not cropped. I just want to see what's the difference in terms of visually. I just want to see what's the difference. Just crop. Yeah, this is better. Padding 10, currently title cut off. 50 medium and large padding should include title. What we'll do is that we'll basically uh, we'll make we'll make padding 70. No crop will give the full text. Yeah. Oh yeah, no crop means, yeah, of course I forgot. Yeah, it'll get the full page. I was like the entire thing. We'll just add 70. Mm. I would also just for safety, uh, if you solve it for 70, then you don't need any. I'm just thinking if there's anything incorrect, anything incorrect or something, but it's okay. 70 should be fine. And just for safety, again, one for safe. Again, we might not need it, but just for safety, we'll include above 250 chunks and below 250 chunks. And we have to clarify this clearly to the model, saying that this is only just to give you context around what's happening in the adjacent page. If it's useful, use it. If not, do not worry about it, sort of thing. Okay, 17. Now for this page, there is some, I mean, this is huge, right? But usually if I scroll up over here, if padding is 70, then this table will also be part of it. Like it'll be part of the same padding is 17, meaning if you, this would be captured, and then you will also have half part of this table, then it'll be a confusion. So that's what I'm just saying, if padding makes sense or not. But it's okay, we can just keep it as this for now. I also want to know whether it's padding size of the image. For example, padding 50 for this, will uh, will it be, I think 50, is it 50 pixels of the general image or whatever? We have to test and see. So let's, yeah, test and see. This is right here, but they should give an accurate picture for now. It's more than enough. I think we'll work on hierarchical chunking. I think I think we'll just wait and do it because we need to have that order of table. We have to have the order of formulas and also the pictures. All three types of data should be available for us to order it and make that useful as in as a final chunk. And above, I guess we should not forget, we also should do it next. Let's just spend the next 30 minutes and just wrap this up. We have to also write symbols, and we also have to yeah, work on the title page, report page that provides helpful metadata for all of the documentations. Okay, we'll test it. Use VENV. Okay, what I'll do, I'll actually run this. See what. Okay, we'll see with the padding how much of. Yeah, can you see? I think no. Okay, this is accurate. Very good. I thought it's probably half half of an image. This is okay. Good. 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 This is also good. Yeah. Missed table. This is also good. Yeah. So table two and aluminum gel propellant. I can confirm that's true because I've seen it like a dozen times right now. Table three. Three. Sorry. Gel propellant properties. Formulation number state. You'll have gel propellant three. Formulation number state persistence. Sorry. Correct. Yeah. Format this now. Now you can, of course, you don't need to waste tokens, but I'm just lazy, so I just pass it and let Claude see it. I can also visually clean, like it's a clean representation, so I can just see it and I can square it if I want and change things up if I have it in Claude. So table two, I think, yeah, this is last, right? So we'll just leave that as it is, and you can the values in the weight percentage 60, 58, 16, 36, 20, 1.4. Accurate, very much accurate, and very simple stuff. So, and also you can see the notes here as well. So it's okay, that's good. Table 3, 5, I don't know what you call that, but 400 freeze value, aluminum RP, 1 gel propellant properties, and if you scroll down, it's 0.883. This is not measurable, that's also right. 13 split in the third one, which is also good, and you've got all of this as well. This is also right. And for all results, this is also good because it's very important information. Like the table, just with the table, it wouldn't just make sense. You need to have this. And also, I think these are part of symbols. We will extract that and give more info to the tables. That's what we'll do next, I think. And then we have tables. Yeah. Particles, images, results, mass photos, okay. Some chemical form, gel compositions, etc. Right? And this is very good. Yeah, looks good. I ran it and it actually works. Now I would like to now because we handle missing tables as well, right? The rest of the processes are in order, so that's totally okay. But for the missed ones, we just need to put them on the right order. The apart from the currently the missed one is actually being processed at the end, so it's on the end of the array. But I want it to be on the uh, right position or maybe the right form right layout. If it's on the if it's before if it's before a graph, then it should be on the initial level of graph or whatever. Currently the 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 rest of the detected tables are working fine, so that's not an issue at all. Only the missed ones. How could we solve it? We probably can do it with bounding boxes, or we can use position or pages or whatever. We have to find something accurate because we don't want to spoil the rest of the other calls because the rest are accurate. Only the missed document is inaccurate, or maybe the continued one or whatever. So we need to solve just for that. And also you can't we can't accurately like you can't be accurate in page numbers as well because a single page might have multiple tables. So if you were to uh, sort it by page numbers, which you can will but might be inaccurate if you have multiple tables in a single page. So you have to, what do you call, you have to you have that in mind too. No, you don't need to sort all the JSON, and you don't need to depend on page sort, because I'm saying a page might have many tables. You have to, you have to, yeah, you have to probably be dependent on bounding boxes or something, I think. Yeah, it provides a vertical position, right? Even though it's a couple of pixel up, or like the starting point is greater than the starting point of or like, yeah, not greater than but less than the start vertical position of the other table, then it's probably up. Then you put it in between. Good day we have the sort of we have the locations of the boxes. So higher on the page comes first. No, actually. Okay, yeah, top wise, yeah, higher. I think so. We'll see. Yeah. Now, so far we've only like we hope that the what like the text below it is part of the same, like it's part of the same image. But usually there's a good chance that you might have even text below this. So then what you can do, just pass the text. Like, just be safe enough to extract the text below and up and just pass it. But right now this is okay and fine. So just leave it as it is. So it's done and good, good, good. And now if I were to paste this is in the extract order. I can see it here. Summary of metallized propellant property considerations. That's the first one. Before it was the actual last one, because it was a missed table. So we'll go through one more time. Table 1, 100% right. Cool. Table 2, right. Table 3. This is quite complex, but it's right. Table 4, right. Table 5 is also right. Table 6 is right. 7 is 8. And 8 is right. Yeah, guys, this is awesome. Yeah, the extraction works very well. All right, so we pretty much solved this main point, and now we have two things remaining. One is working on symbols, and one is working on what? Working on oh, totally forgot. Working on, if you should be on the page. Okay, working on this report documentation page. So first we'll work on symbols, and then let's work on this. Okay. Nomenclature. And I was doing this research, it's like nomen in talks. And it's pretty standard as well. Oh, so I'm not nuts. All right, now we need to do something else. Now, usually in a rocket document, or maybe at least the documents that we deal with, there's a lot of there's symbols and like, symbols which is usually used throughout the documents, and these sort of defined what the meaning of each, I don't know, what of the symbols is. I think those have to be 100% captured and sent to the tables or to any images or any VLM stuff that we sort of process it outside. that has some synthesis, because this would actually give you an accurate meaning of what that symbol is, to be able to like make, to be able to accurately give description to it. Second thing I also want to work on is a report documentation page. No, we'll actually come back to this later. Just not confused from now. No, I'll play as if I'm a dumb person, right? Let's say let's say I could be dumb. I mean, I am dumb, but I'm just saying I have no clue about the rocket science stuff. I have nothing. I I have no clue about anything on the symbol side, right? So I'm just, you can just directly ask it. I just literally want to know more about the docs and what is this domain, and literally want to know, like, uh, how much of like how like uh does all the documents have symboled, or the sort of documents sort of the table of content, or sort of symbols that defines certain variables, and is it a norm in all the docs, or how is it, and how many pages are the symbols, and I just need to really know how on a naturally how a document would have this sort of information, or any other information that would probably be present in all or most of these relevant rocket science docs. So basically I just want to know, sorry for my English, but hope you get the idea. Yeah, so what I'm trying to say is that I need to understand, is it only symbols, or is it, do you call it something else? Is it because I saw it symbols, it was symbols in different other documents as well, but you might call it as something else, right? Like something like variables, or something like, I don't know, maybe variables or whatever. So I just want to make sure that we are not just solving symbols. It is symbols, but it's not what do you call it? It's not it could mean differently. You don't literally want to mention it as symbols. You could probably mean something else, like variables, or maybe like you would have like an image, or tables, which is a table and not a symbol, and it like detection might work in a very incorrect way. So I don't want to complicate this. Simply, I just want to know more about the nature, or the generality of a document, so then I can try to see patterns. That's what I want to do. So I'm going to send it. But I did a lot of research on this, so this is very, what do you call, this is very standardized. The report pages are also standardized, and it would be no more than 2 to 3 pages most of the times, and it's very it's quite, what do you call, it's quite yeah, it's quite concise as well. It's not like it's not like an essay, and it's not more than 3 pages, to be honest, most of the time. So do not explore the document. I'm just asking you because you're already trained on it. I usually use Claude for this, but you can just ask Claude Code. So that's what I use until this year gives and give the service and come back. So I usually have this pattern where I try to understand the domain more, and also understand the structure we're working with. So because like like we only can see a limited number of documents, but in reality people who work on this domain will actually we've probably seen like 20 years of documents, and they have so much information to share. So you have to do a lot of calls. You also have to understand the domain. You have to have like general sense of like what you're dealing with. You don't need to be a scientist or a researcher, but you can like understand what their work is, level of ethics of work, and then try to understand like the general parts of it, like how a document is structured, and what are the terms they use, what is the way they use, and how do they approach things, how is the search pattern, etc. We'll go through them when we design the agent. That'll be most. So when we design the agent, we'll actually try to get into the shoes of Sandra, which is one of our test customer, or the person who'll be using, or maybe you can see that in the last video, or maybe we'll be in the shoes of the actual user, and try to get into their brains, and try to see uh, how would they search, what would they search, how would their queries be, because we don't want, the system is not going to be used by a general person, right? It has to be very different. So those are like good points we can take from them, and sort of build it in a very niche way. So anyway, yes, symbols nomenclature is clasher. I think you please spell it like this: nomenclature. Sections are standard in aerospace documents. Typical document structure is title, abstract section, Yeah, but this is actually at the end of the page, not right after TOC. So you can't like you can't do any like you can't scan for TOC and then try scan for symbols, or maybe even that will be very incorrect. Like you'll probably end up wrong, because I've seen in, for example, even this document, if I scroll down, there's a ton, there's okay, abstract, introduction, there's discussion, and all of them like and then fill information, results, and everything. And then you have appendix, glossary of terminology. I guess this is fine. This stuff will be mostly solved by domain terminologist. But then you will have references, and then you have tables, and then you oh shit. Actually saw symbols somewhere. Oops. Okay, maybe that's symbols or whatever. I don't know, but I did see symbols. All I'm saying is that you can't predict that the symbols would be under TOC. Sometimes the documents might not even have TOC, so you can't make that prediction. Now this doesn't have, but I'm pretty sure documents do. Okay, this you can see you have a ton of information, and then you have symbols. Your appendix have symbols, so you can't. And then you have symbols, right? So yeah, all I'm trying to say is that you can't predict it. Like you can never predict it's on the TOC or whatever. But simple nomenclature, when it says whatever typical length 1 to 3, yeah, exactly. So 1 to 3 pages, not more than 3 pages for sure. And when your Williams says the table, that needs to know efficiency without this context. Okay. So what I would probably want to do is that I want to do it in first two passes. So the first, I'll just tell it here. So I want to get it very right. So let's have like a two pass approach. Uh, First, what we would do is that we would do some semantic search and try to find the symbols. Basically, what we're trying to do is that whatever text that mentions the word symbol, so whatever text that talks about symbols or some text or chunks or whatever talks about symbols, we'll get not adjacent, but then we'll get the entire chunk, about 300 to 400 chunks, and then we'll pass it to a model and let the model decide whether it's just whether it's a paragraph that's talking about symbols, or is it the actual symbol section. Like for example, this document has what I really mean is that symbols. I'm going to search for symbols. You have symbols, but you can see in the text you have the symbols, right? And if I scroll down, you have in another paragraph you'll have symbols. So what I want to do is that pass this particular text like this if it comes to symbols, and again if it this does also mention symbols, so we'll probably pass this as well and then send it. And it's only limited for like not even four, yeah, and it's only limited for 300 to 400 chunks, yeah, and it's very limited. And then based on it, the model can understand, okay, this is the section of symbols. And what I will do is that I know generally that the nature of this document, the symbols will not be more than 3 pages. So what I will do, I'll take the first screenshots of first 2 pages above, and then screenshot of first two last two page like last 2 pages from this particular page. So it'll be the first 2 pages, this the current page, and the last 2 pages. So total 5 pages. Or we can also do like just extract it. I don't want to do extraction because you can see there's a lot of formulas as well. So I don't want to. I want to use a VLM for this as well. So just to be on the safe side. Because this, in case this formula, if we get this wrong, then I don't want to get it, like I want to get it wrong. And also VLM is quite efficient here as well. You can, these are very simple info, like baby stuff, right? I mean, the meaning is quite complex, but there's like nuance. So like for example, see this CV, it has a lot of nuances. You don't want to, you can't capture this in a chunk. The chunk will be like C and V. It won't predict this. So let's do that. um Yeah, moral, whether it's a paragraph or talking about symbols, actual symbol section. Once you identify it, send the current page to the LLM, send the above two pages and the last two pages, not last two pages of the document, but last two pages from the current page. So it should be, if the I mean, you'll get it. I think that's it. If so, this should be the second pass. And yeah, this should accurately give us a list of symbols. And also prompt the model saying just to accurately give us the symbols as it is, as in a markdown or something. Simple, that's it. Like once you figure out where the actual section is, and the good thing is that we know that symbols are in a contained environment, or they are in a contained space, and it's no more than 3 pages. So when you know there's a constraint like this, or there's an info on this, you can basically build it for that. If not, if you were to go ahead, if symbols are mentioned in, if the same symbols are defined in like very different sections of a document, then it's hard. Do you want to do like rag search, and then you have reasoning, and then you have all of those stuff in order just to figure out where the symbols are, because anyway we have to solve that. But this is simple because they have said of this thing, it's no more than 3 pages. You just have to find where the symbol section is, and then you read the first two and the last two, and then the current page, and you mind map it. Right, that's it. So just to make sure that this Claude is not assuming things. So like, do not assume anything. Do you understand what I'm trying to say? I usually sort of send something like that because I've had bad experiences. Claude just assumes things and just the code, and once we test it, it's complete crap, and we have to waste a lot of time, more time. So I don't want to spend that. So if we were able to solve this, it'll be something similar for the reports page as well. Now reports page, I think it's even more simpler because I think it's only one single page. Um, this doesn't have a reports page. That's okay, but this did have a page. I think reports page. Okay, did no, we don't have a reports page as well. And even though I know NASA provides us with a lot of metadata, but I'm not going to use any metadata from them because usually in a real setting, you have to find metadata. You can't, like, no one will give you pure JSON with the author's name, with the abstract, with the date created, and all of those stuff. You won't get, yeah, you won't be privileged to access all of that. So you just have to do a lot of parsing, rejects, a lot of VLM calls, and then try to figure out things. So I'm not gonna, even though we have it, I showed in the first live stream, we're not gonna use it. We'll just do it in the hard way. We'll extract. I'll show you how to extract metadata from the reports page. Now we know there's a reports page or any other metadata. So we'll finish this. So two parts, one detection semantic search for chunks, normal question notation for each hit, grab a chunk here, correct? Chunk to an LLM is an actual symbol or paragraph mentioned it. Element of true and false. Once you get it, get the current page where it found, get the 2 pages after, and send all the 5 pages to the VLM, extract the completion. Yeah, very good. Yeah. Proceed with this. Proceed with this. Find missing tables, and you can see item not label, which is the label is actually also, guys, until this is going on, so I think let's do the work. Let me just check this code. To pass symbol. Okay. Call VLM format the images. Classify hits. Pass one. Classify hit if it's an actual symbol. Returns true. Last takes expert. Yeah. And then pass two from the images has to be accurate now. So find keywords. So we're doing keywords. We can actually do semantic search. Um, but if keywords is okay for now, you'll call it symbols, and most of the time it'll be symbols, I think. If not, you have to chunk it and use it as chunk. But for now, we'll just work with keyword search, and if it does it, then we can update it to semantic. Not a big deal. And also, guys, in the middle, I just want to do I just want to do like a same a quick what do you call? We call it a shameless plug. But yeah, so this is the project that I'm working on. It's called Intraplex. So whatever you see in this video is the learning that I've got from building a system like this. So this is a system that runs 100% entirely in your 100% entirely in your servers for air-gapped environments. So we work with a lot of banks, not work. Yeah, we literally like we work with, meaning I've in my past experience I work consulted for a lot of banks and stuff. So we're launching this new product. Essentially is that you can run deep research agents, you can use open source models inside your secure environment. So let's say you're a bank, you're dealing with a lot of financial data, you have a lot of policies, and you can't expose those data to the cloud, which is what a lot of the banks do. We've experienced that thoughtfully. We've had a lot of conversations with the bank, and we're also going to do a POC with the bank as well. Yeah, essentially, if anyone is quite interested in using a solution like this, if you're a pharmaceutical company who is protected by a lot of health regulations, if you're a bank, a lot of banking regulations, even if you're like a even if you're working on rocket research, or if your team is working on research, anything in the rocket side, we also support this. So this system will not just handle rocket science stocks, and handle finance, pharmaceuticals, uh, oil and rig docks, and whatnot. So it's basically a one single place that you can. Uh, I wouldn't call it one single place. Basically, it's an entire system. It's an on-prem system that you can host it inside your cloud servers if you want. Sometimes some of the companies will also work with rocket. A lot of the rocket companies do have their own ITAR protected servers. You can host it in those servers or even run it locally as long as you have the GPUs. And this could actually work with very minimal amount of GPUs. With non-vision stuff, we even support 20 billion models for just doing NLP search, which a 4090 is more than enough. If you want to do like VLM stuff like what we're building right now, you could also just get away with it, like one single 5090 for a couple of people. We manage loads and etc contexts as well. So it's like one single platform. You connect all your tools. We build and connect your databases as well. It also connects to Postgres, SharePoint, Redis, ClickHouse, any database you can think of. And yeah, and it also supports models. We keep updating the stuff as well. And it uses everything. It could work for more than 100,000 documents, but we definitely will do like a POC initially and then roll it out slowly to the teams, because we need to understand how each and every guys, like how the solution should work for each company. But yeah, if you're interested, just schedule a demo. Feel free to schedule a demo, and happy to talk. But then yeah, this video is and this code is will also be production ready. That even if you're like an aerospace company, you're a director of a research company, you're a director of whatever, like you're working with NASA, and if you want to use a system like this at scale that's reliable with support and etc., feel free to hit us up, and our team will be in touch. Cool. Sorry about that, guys. I just wanted to, sort of quickly sort of mention. I think if it's helpful for few people, definitely feel free to reach out. But it's not like sales or something like that. If not, I'll probably wouldn't share all of this information or build it in front of you guys, because these are some of the IPs or sort of like things that are sort of figured out. So it's cool with that. Anyway, two pass decision is done. Let's actually move on for the next one after testing. So let's test it from the first place. Okay, no symbols or keywords detected. Okay, maybe we're dealing with a different PDF. This is one 424 PDF. Let's see, 424 PDF. Yeah, it doesn't have any symbols, so not this, but 428 PDF. We actually have symbols in this page, so we'll use this PDF. And that's correct. Like, if there's no symbols, and there's no symbols, we wouldn't send any context. We don't save as well because we don't have anything. Maybe with semantic search, we might find info. That could be a chance. But yeah, for now, like for just to solve it for now, and these are like very good stuff to work on. Like nice to have later on point of time. For now, we'll just figure this out. Keyword search is more than enough. Just move on. Yeah, I think the prompt has to be updated because you can see the following symbols are used in this report, which is exactly the symbol section. I'm not sure how many chunks we are, not chunks, how many chunks we're sending in the first pass. We have to send more, I think. So the first pass, you don't need to send it as an image. You have to send, you need to send the chunks, meaning you need to send 400 chunks. How many chunks are you sending? Says prompt, I guess, can be very, yeah, prompt can be simpler, to be honest. I'll probably do something like this. Process, I see. Right. Yeah, I think it's working. Cool. This. Cool, cool. Extracted symbols, I guess as 10. And hopefully is as far as you can remember. The 10th one is exhaust nozzle outlet. And we got it. Nice. Got it. So it's extracted using Greek letters and strip. All right, now pass this. Okay, I think. Yeah, so we'll have the pipeline. So there's like now we do symbol processing as well. Now, once we convert it to a single pipeline, we would then do it. Just make a note in the code that when we create a single pipeline, we would actually manage all of the symbols and then passing it to the tables or figures, documents, etc. So just add it as to do. What the shit is this? No, I meant add a note to the code that we will integrate this to the production code very soon once we have the full pipeline. Yeah, cool. Now I wanna. So we can try to use that. Okay, you can see over here, we get symbols over here. So this would probably be accurate. It'll probably extract the symbols. Oops. I'm just trying to get in hold of that report page from this page. Okay, I'll take a screenshot of this. All right, now I just noticed one single pattern from when reading the PDFs. Some of the PDFs do have a section like this. I've attached it as an image. It's probably in the beginning of the second page of documents, or probably at the end. It's probably in the beginning or the end, and it provides a lot of metadata like names, the abstract of the document, and so much of information. I think we should process it and save it. I mean, so much of metadata for a single document, which is really gold for us. Now, I would really want to like to understand in a general sense, what is this? What do you call this? Is it the page? Is it the report? What is it? And what docs? Like, what docs? In 100 docs, how many docs would have this sort of section? And like, and yeah, how? And yeah, just that information. That's more than enough. And what do you call it? Just want to know like any background context, because there's a lot of unknowns. So feel free to educate me on that. And not waste its image. Yeah, okay. So it's called a report documentation page or standard form 290. So it's a standard metadata by required by the US government for all technical reports. Managed by the Department of Defense and adopted by NASA, NIC, DOE, and other facilities. Usually the last page, back of the page, sometimes the second page after the title page, occasionally both. Usually the last page, back cover of the document. Sometimes the second page after the title page, occasionally both. Equivalent. For NASA and NC technology, 100%. This format has been used since 1960s. Any document with ID is like, okay, sweet, okay. And TM means technical memorandum. Okay, this is gold, guys. Like if you were to, like for example, if you were to NASA TP, if you were to get like TP basically means technical paper, CR means contractor report, RM means research memorandum. So I mean, instead of even processing the document with just with these ideas, we can extract like what sort of document is it? I think so. We'll have this page, report number, all of this. Very good. Yeah. What is goal structure? I would say what we can do is that we can search up. Uh, the thing is, uh, the thing is, if we were to do, what do you call if you not sure if it, I want to know if this is NASA specific or is it like like does aerospace docs have something like this in common or is it just NASA? Because I can see it's everything is NASA, but I want to know is it like NASA specific or in any is it like an industry norm or like even if like the SpaceX used the same format even on internal docs and etc. I just want to know that. Okay, so SCP 219 is a US government standard, not aerospace specific. Who uses it? NASA, Department of Defense, Department of Energy, and United States. For any federal funded research, who does not use it? SpaceX internal docs, Blue Origin, Boeing, Lockheed Martin, a private aerospace company. They have their own proprietary documentation formats. However, if SpaceX does NASA contract, deliverables might have SF298. If Boeing does DoD work, those reports would have SF298. Internal docs, company space, etc. Okay, now of course we can't go inside SpaceX and look what like their documents, right? We'll never know. So I mean I can pull up some documents and spend time on it, but it wouldn't be accurate. But yeah, essentially your docs, and because they have their own standards, right? And standard could differ. Your docs are NASA technical reports. Why is why 100% of them have these pages. If you have SpaceX in different format, with Java, different format. Um, cool. So I mean, because we're building for NASA, I think because we know the format, if you were to build it for any other agency, Space NG is totally different. Because it's specifically for NASA, we literally know these documents do have this sort of information. So what we'll do, we'll definitely send. Yeah, what do you mean send what? Uh, we'll extract this information. Now the thing is, we can't send the last three pages because see this is one page, this page two, this page three. Now that's inefficient way of content consumption, and our assumption is that it'll be in the first two pages as well. But what if it's in the fourth page, or what if it's, if if first two three, like just see like it's these are scanned copies, right? First one, so you can like, there's like unnecessary page is available over here, and you have this page, and you have TOCs, maybe some of the TOCs. So you have to accurately find it. Now the thing is, if I were to just bluntly look at this, there is no title, like there is no, there is actually no title. But what you can do is that because this is a standard, you actually can see there should be a report number, and the report number should follow this value, like NASA TP-192. So we can do a regex for it, and that should, we don't need any, and we can easily find the particular page, and then the send the first, and just send, I guess it's only a single page thing, just send the single page and you'll get it. And because report number, this is just standard, so this is just standard. So I'll be like mhm. Cool, actually let's build the extractor. Now it'll be very inefficient to build to pass the last three pages of the first page, because scan copies could have extra pages, what do you call that? blank pages and etc. So it won't be inefficient. So it will be inefficient if we do send 3 4 pages up and down. But what we can probably do is that, because this is a standard thing, the report ID or the report number, whatever you call it, with that NASA or whatever, is actually a standard. So what you can do is that we can probably do like a regex to identify where the report ID and that NASA or whatever, whatever, it's a standard, right? You can build the regex for it, and then we find the right page, and then we just send the exact page. I mean, I'm probably most of the time I hope that the report doc will be in a single page, and that's the exact format. If you want to add some, just for verification, want to add check for another 2 or 3 rejects, because you know what the standard fields are, you can do it. But I guess report ID alone is more than enough, and you can try to grab it. And feel free to let me know if this is a wrong approach, and yeah, I could miss any information. I literally want to tell this as well, because I might naturally I would miss any information as well, because I'm not an expert in this field, right? Like the model knows better than me. So at this case, I'll probably rely more information on it, but still make the decision. So we just send it. And this is the reason why, guys, like it's very hard to uh, it's very hard to build one single extractor, one single document parser that works across documents. Like documents are like, I don't know, documents are like systems. Documents are like, companies. They have their own company culture, they have their company ethics. Not ethics, by the way, they have company formats, their company standards, templates, and etc. Like if you were to understand the standards and etc., you can just build accurately for it. And for example, you can't, like, we can't basically give this system to a finance, like this system can't work for a finance domain. Like you upload some documents and it'll start searching for report IDs and NASA stuff. You understand, right? It'll be a mess. So that's what we, select the domain, build, understand the nature of the documents, the nature of the specs, the nature of the history of docs, and then try to generalize the concept so it works across NASA, SpaceX, or anything else. I mean, not NASA specific, but just that domain level of documents like rocket technical papers or memorandums or reports or testing phases and etc. Um, yeah. So the CPS, yeah. So it's rejects, and this is also a very simple code. Thank God there is one standard for it, because if people were to rename it report number by something, or report number, or report ID, or report document ID or whatever, it'll be probably hard for us. But because this is authorized or be standardized by NASA, 100% of the time the papers will probably have report number and number, and will probably have the same ID, so we should be fine. No, also you can use a lot of regex to, for example, what you can do is that you can generally, I guess, a very simple page. Docklink has its own 250 parameter MB model. Sorry, not 250 parameter, it's 250 MB model. You just, I think it's MB or GB, I don't know. It's 2 GB, under 2 GB, something on, I don't know the exact size of the model, but it's a very small model. You can run it in your PC, and you can basically extract all this text from that itself. I'm going to use a VLM for it because I can afford it, but yeah, the very simple, right? Like the abstract is like not even 3 page, like very light 2 page abstract, so it's okay. But I'll still go with a VLM. So we'll be like, we'll test this PDF, and we have to see this particular markdown. It's called tool diagrams images. Cool. If this works, then we are done. Not done. We can move next to chunking. Oops. It's actually, hmm, actually has a report documentation page. They didn't find it. Not sure why. No, the thing is like, guys, I don't know how much regex could be accurate because this old documents, when you pass this report will have R space E space P space O and RT together, and then N node dot will be after five spaces. And then the NASA will be in dash in or three or three or four lines extra. I don't know what you mean that, but yeah, basically you'll have like extra lines. Like you can't even predict that. I don't know regex will work here or not, but let's see. Can you see that? Yeah, exactly as I predicted. It's RAPO and the space R space T and then O. It's so weird. Instead of report now, and you can never fix it. Uh, then that's good. I guess it's searching for more regex, like abstract, because these are what do you call it? These are standards, right? So yeah. If not, what we have to do is to do semantic search, then again do pull three, 4 pages, waste tokens. But because we have standard, we basically can weight those standards and pattern match and try to find the right ones. Yeah, I think you got. Yes. Yeah, 1932 is the ID. TP. Uh, Sponsoring agency name. National Aerospace Administration. Prepared by Data and Laboratory. Fight Computer Branch. Yeah, got it. Beautiful. This is gold. So this is making it. And now of course, the pipeline is not yet working, but eventually what we need to do is that we have one pipeline where you drop in a document, it does the it checks for figures, tables, symbols, what do you call this metadata, and etc., and then do a whole bunch of stuff and then do it in one single pipeline. So we have just done, like, the thing is, I've I have a lot of unwanted code. Like you can see the ton of images are, we have a lot of folders, a lot of images, but 90% of stuff is like we don't need this. We just get rid of that. We just need the code. But as we test it and we just move on, it's not the neat way of doing it. I've just yeah, I, I didn't plan for it and we had a lot of issues. So tutorials could be very clean, but this can't be. So at the end, when I send you guys the GitHub repo, I'll probably get rid of all the test stuff and just have the code. And if you see code wise, we have like 5 processors and one pipeline and then one document for managing. I mean, maximum like 12 lines of 12 files of code, to be honest. Yeah, quite simple. And the fixes make a rejects. Yeah, this is good. So I'll be like, yeah, looks good. add a note to the document that we should come back and add it to the production pipeline once we have a full pipeline, so we don't forget this. And see, you have report number and you have title, and let's say, um, we just assume one user is going to search for, let me scroll up and see the diff. Okay, technical paper, technical memorandum, contractor report, and a research memorandum. You have 20 files for each. Out of the blue, the user just comes up and says, "Hey, find me a technical memorandum from 1996." Now, the technical memorandum will actually not have, I don't think it'll have, the document itself it probably have a different title. It won't be like, this is technical memorandum by NASA or something like that. A keyword search or a semantic search would fail. But because we know the standard documents, they follow a standard. NASA TP means technical paper and TM means technical memorandum. So what we can do is that we can use this metadata to sort out um, all all the documents which has NASA TP, which is a technical TM, which is technical memorandum. So we're basically avoiding. We don't even in our RAG. We don't even look at technical paper. We don't even look at contract report. We don't even do embedding stuff for research memorandum. We are only gonna look at NASA TP because TM, because we know it's technical memorandum and there's a unique way of identifying that. So I need to have this context. I'm gonna basically go ahead and save this in a Notion notes. So this will be used when I'm doing the search part. So we have to um, learn more info on this and try to build search around this. Yeah, just add it as a note. We'll just come back and refine it. But this is like, this is really good. Like, you can literally sort technical papers without doing any embeddings, but just by doing NASA TPN, you'll find all the technical papers as long as it has a report number. Of course, this is, I mean, you have to do all the search, you have to do the reasoning, you have to find if you're cross different, like referencing things, you want to do all of those stuff. But this, like being able to just find the stuff in 10K documents, that if you want to sort it, that's really helpful. Like that's really assist. If you don't have, that's why metadata is very important. And each documents provides, like, you can access metadata in very different ways for very different documents. But this is gold, as it's actually it's only because it's a standard. So, okay, so we have title, that's also useful. Title, of course, you can do it in everything. Report date. Now there's two way. Now there's, let's say, now the actual scenario is that this paper was sort of this paper was, I don't know, not written or whatever, published or whatever, or probably were created at 1981, but the PDF scan was probably on I don't know when, like, scanning was created. Scanning was created. When was a scanner created? Oh shit, 1860s. Oh, I was like, I thought it's probably 2000 or something. Okay, cool, whatever. So probably they scanned it, or probably they scanned it probably the report date was 1981, but they scanned this and computerized it probably in next 10 years, probably in early 1990s or something. There's a 9-year gap. So if you were to pull in PDF extract or PDF metadata, it wouldn't have metadata. I'm assuming it might not have metadata. Even if it has metadata, it'll probably be 1991 or 1992 or that early date. And if you were to just get the metadata from that and then search it up, if the engineer were to say, hey, find me docs in 1990s, you'll pull the wrong document, but the document was actually originally created in 1981. So they are, I mean, that's not an embedding problem, that's actually a metadata problem. So this is very helpful here because you get an actual date, because it's written that November 1981 is the date that this report was published or written or whatever, and we have a clear idea on that. And author information is also, um, I think because I'm not still in this domain, but at least I think author's information could be very helpful, because if you want to search certain documents written by a certain person, if you just can recall certain things, and you can basically search it up. And sponsor, I don't know how it's useful for me, but I'm sure all of this information is gold for the users. Abstract, you have the full abstract, very important, because usually what I do is that not for all the documents. When I built not 10,000 documents, that's not 10,000 documents, but if I'm, because at 10,000, you don't have the privilege of sending all the documents to the LLM and creating summaries. Um, But for very small drag gaps, like for example 100 documents and maybe a couple of four digits, like maybe like maximum 1000 documents, I'll probably send 1000 documents and then process a summary, because a summary is very very core, that's very important. That something like you don't need to do a lot of hard work searching stuff in the embeddings and document. Just look into the summary, you get a good hit, then you expand into the document, then you expand to the subsections, and you could go on like how a user, like a human would search it. Like very lazy and a simple approach just works magically well. You don't get a privilege to do it in any, like if the document is more than 75,000 tokens, or if it more than if it's if it, some documents I've seen, they're like 300 pages long, and they're like, I don't know, 75 to 120,000, easily more than like 75,000 words. Then I wouldn't send it and process just a summary, because it's very inefficient. Just think like sending 100,000, sort of 100,000 tokens and just getting like less than 500 chunks of summary doesn't make sense. For that, I basically read the first 5 pages, last 5 pages, randomly read, things in the middle and do. But this abstract written by the person who wrote the report itself is very very, basically, like if you're processing 10,000 documents and you have 10,000 abstract, that's like gold. Like you wouldn't even find this in, even if you train stuff, you probably have to, a lot of the labelers do go through the document, and they won't go through, and they're the third party guys, right? They'll probably just skim through the document and they'll just write the assumption as the abstract. But in this case, the author probably wrote the abstract, and it's very much accurate. So we can highly, so when I design the agent, I know who wrote the abstract, and I know where is this from. The author probably wrote the abstract, and how long is the abstract, and etc. I could encourage the agent to trust the abstract a little bit more compared to the other AI generated stuff that I usually do. So this is something that the agent can slightly sleep on to find more information across documents. So I know that because I can get a feel of the documents that exist. Okay, we'll send this that do exist. So we'll just send this note to basically add it, so we can look back when we have the production. So I'm just trying to explain this thing to you guys because like it's like chunking stuff and all are very easy. Like you just get chunk chain, put in whatever documents if you want, even 100,000 documents. If you have you can just process it overnight for weeks in your PC. But like actually building a solution, but and also understanding the space, understanding the domains, understanding doing pattern matching, and understanding like why understanding whatever is in your favor, like whatever, like for example, we use so many things in our favor, so much, and there's so much custom for just for this aerospace docs. So just use as much as possible, and and yeah, and try to be try to find that sweet spot, and then it should be easy. That actually it's not rocket science at all. um the note is already there, it's added. Okay, cool. Okay guys, I think that's that. Right, next I think it's we have to merge this into one single code, and I think once we merge it into one single code, we can um, yeah, we can. I was talking about the entire pipeline, right? We just do the entire pipeline and test it one more time with a couple of docs, and yeah, we can see what we can do next. Then. Yeah, we have domain terminologies. That's up, not now, a bit later. This is okay. We get both of this stuff. All right, good. Now I want to combine everything into. Okay, I think we do. We have this chunking left. I think we have a hierarchical. How do you spell this? Hierarchical. Sanjay, how do you spell it? Mean hierarchical? இல்ல இப்ப சொல்லுங்க hierarchical hierarchical. Okay. Whatever. Anyway, we'll work on the chunking part. Um, okay. How do you spell this? It's fine. Because I didn't even. I thought it turned off the FN from transcriptions. It's okay. I think this is left for us. Development. And this, I don't know what's the goal of this. I think it's just extracting all the section headers, implementing. Detect expand domain specific acronyms. We don't do it now because we'll use that's itself another thing to work on. So we'll not do anything later. We'll take care of this later. Technical decisions to be determined. Open questions later. Cool. I think the overall goal is to, I want to do the entire pipeline now, but maybe we have to, I thought we already had sections and etc. So parent-child relation will be sections. Yeah. So what we'll do this and we'll just have to check. I have to basically check whether like the tree of tree change like is are the section headers or the section subsections and all of them in the chunking part is coming properly. And if that's the case, I think it's good because I'm not going to do any work. It's just using docking to do it. For this should be simple, and then we can add the entire thing to one pipeline, format it in one chunks, combine those into one single final chunks, and then chunks should be ready. Then we can talk about whether we want 256 chunks, we need 500 chunks, or what, like do we need to re-rank all of them. Or you already have a record implemented. Oh, we already have it then. Mm. Okay, this is good. Good, then this is good. So then we need to so then we have to make this or whatever into one single pipeline where I give a PDF. It should um do the image processing, the figures processing, do the formulas, the tables, extract PDF as the production one, I guess the latest one we was working on. And yeah, whatever we did all throughout in the few all throughout in research POC, even in the normal code, we have to merge this into one single pipeline. Mm, yeah, we'll just send it. That's it. Nothing much complex. We just have to reuse the same code and just put it into one simple file. To be honest, yeah. Symbolism and culture. Extra report tags. Uh, okay. Sometimes percent at the time the papers would probably have, and rocket a lot of the rocket companies do have their own. We should be fine. No, also you can use a lot of regex to, for example, what you can do is that you can generally, I guess, a very simple page. Docking has its own 250 parameter MB model. No, sorry, not 250 parameter, it's 250 MB model. You just, I think it's MB or GB, I don't know. It's 2 GB, under 2 GB, something on, I don't know the exact size of the model, but it's a very small model. You can run it in a PC and you can basically extract all this text from that itself. I'm going to use a VLM for it because I can afford it, but yeah, the very simple, right? Like the abstract is like not even 3 page, like very light 2 page abstract, so it's okay. But I'll still go with a VLM. So we'll be like, we'll test this PDF and we have to see this particular markdown. It's called find me a technical memorandum from 1996. Now the technical memorandum will actually not have, I don't think it'll have, the document itself wouldn't, it probably have a different title. It won't be like this is technical memorandum by NASA or something like that. A keyword search or a semantic search would fail. But because we know the standard documents, they follow a standard. So I think this is the implementation plan. Phase one, document processing, complaint extraction, uh, yeah, and VLM processing, phase one output. I think reports, yeah, that'll be the initial one. And these have, like, it should be context across all of those, I think. Create pipeline, shared context passed through all phases, PDF architecture, phase one, simple report data, phase two. Yeah, this is kind of basic stuff. We've already done it. Yeah, these are the settings, so just keep it as. Apart from that, I think it's all good. Verify everything works. We have acceptance criteria over there, and so safe to go ahead and yeah, but approve that. Hopefully, you should do. But I still want to. I don't wanna. I don't do auto accepts because it'll mess up. Usually, it does like some stuff in between. Like you never notice it. So for safety, I usually review all the code and then sort of manually do like an enter. So okay, there it is. It's like pipeline. Simple system. The charger. Straight. So orchestrate all the extraction phases are complete with discussing extraction. it's okay to have this what do you call hard coded single file for now. It's easy to debug as well. Not very easy to debug, but at least you know where the issue is and get a chance to check the entire code as well. It's okay. Later we can dissect it and make sure they have like other functions and etc. It's okay for now. Except formulas variant 4. Okay, I think it looks good. So, actually, the model could have copied and pasted it and then made changes where it's okay. Okay, yeah, this is good because we have all the prompts. We have set picture prompts, git formula prompt, prompts are separate, and then you debug. Good. This is good. Vale. No, okay, guys, I'm gonna let this run. I think, yeah, it's auto compacting, and yeah, mostly done. You should just fix this, and we should be done with this, and we get started next. Now, this in the modification data. This is I don't think if it's, I'm thinking it's writing some duplicated code. Mm. No, I don't think. No. Oh, we were using llama for symbol LLM. I didn't even check the code properly. Then I will check it properly. Let's just stick with when. Let's stick with this model for symbol as well. Okay, guys, so I'm gonna go take a quick lunch break and come back. Yeah, and then we can. I guess we're mostly done, so we just continue with this later. All right, guys. What do we leave on? Okay, plus a single document. Actually, for now we'll just, I mean, uh, for now we will just keep it as single documents. But later, of course, this is a different ball game. Like, processing hundreds like like depending on the compute infra you have, how many documents you wanna process in a single minute. Parallel processing. There's API limits. There's rate limits, and all of those stuff is there. So we will handle those not now, but a little bit later. For now, we want the document passing to work, and once it works, we can figure out that this is okay for now. But keep in mind, we'll probably work on this stuff later, because anyway, we'll process 10K docs, right? Then we'll work on this stuff. Okay, so then this is enough for now. Okay, so I think the entire process is done. Um, we'll just check it. So two diagrams, images 988. So you can see this. Let me hide the terminal. I'm just, yeah, so there's no automatic verification. Here I'm manually verifying if this is right. And mostly it would be because manually you have to do a lot of work and then make it right. So this is okay. This metadata over here, performing organization. This looks very correct. I think this is from the last page, so let's verify it. Technical expression of special main engine, which provides engine trigger prior to launch, engine control monitoring during launch, and engine safety and monitoring of it. The control represents the unique application, digital concepts, techniques, technology managing, and flow. And yeah, that is right. The ID is 1932. That is also right. So yeah, usually that seems very right. So we'll just leave it as is. And I can see over here you have tables, and then you have. I'll check this table. Test outputs. I think as far as I can see, there's no tables. Maybe it's assuming tables of contents as tables. I think. Yeah. Yes, it's okay. It's still okay. It's not a big deal. Yeah, and yeah, since right. So this is the second one. Third one, it has pulled in some symbols. I think symbols and abbreviations. Yeah, it has so yeah. This could sometimes look like a table as well, right? And table of contents seems like a table. So for some reason it has pulled up. It's still okay. It's just type table, and you have the particular chunk, right? You'll still get an accurate representation. And symbols and abbreviation is also saved as a table, but it's okay. Okay, and I want to check tables of contents. Though, shit. Okay, this is complete output. I think tables. There is no formulas. There is no pictures as well. Hmm. There's actually a lot of formulas, not formulas, but a lot of pictures. You see the chunks. And no symbols are also extracted. About doc pictures. Yeah, some issue, I'm sure. Yeah, so there's some issues with it. Let's just only tables were detected and no formulas, no pictures. Check what's going on. Okay, pictures extraction fail. Pi what document backend objects no. Okay, there's some import issues I think. Anyway, not should be much complex because it's all we have reference code, so it's okay. Let's see this. That's true. There seems to be no formulas, but you have to solve the pictures error. Yeah, I can see there is no formula. Yeah, there is no formula, just pictures and a lot of images are there. Definitely a lot of images. Run it on top. Just a minute. Actually, it says symbols not found. That's not true because there is actually a symbol. Phew, it's symbols and abbreviations. That's what we want to. We actually want to change this into semantic search. We'll change it now. I think it's important. And also one more thing. So in terms of speed, you can see finished converting documents using 41 seconds, 42 seconds. Now I'm running this on a Mac. So not sure how much efficiently these models are optimized for Macs. I guess as you can use it to MLS. I've never tried it, but I just load it on my RAM, just CPU, just basic. I don't have a GPU. Just load it and just run it. Usually, if you're running it on a CUDA GPU, and if you have all the environment variables, everything, PyTorch, everything configured, in a GPU, I mean, you they should cut the processing time nearly by 50%. At least it'll be in 25, it'll be less than 30 seconds for sure. So yeah, that's why it's taking time. Usually it shouldn't. And also we do a lot of batch processing. For example, for each request, we're loading entire like we're loading the entire we're loading the models once, and then we're releasing the models, and then we're loading the like whatever the I guess OCR engines are also loading. I don't know. Maybe it's loading or and they are small. Not it's not a big of an issue, but usually it takes just we would just save this like few minutes sort of thing. If you just not cache it, but you just do it in a single batch, so you don't need to import all of this or load this in the GPU. Already they're loaded, right? This is for testing, so yeah, it's okay for me. So it has found the report, and I think it has also found the images, so that's what they spread. Okay, so images are working, I think, and all of them are, yeah, it's a batch process, so it's okay. It's fast. Test output, and here I can verify mm, pictures, figure one. We'll just manually go through because we have to verify. If we verify one or two or three, then we'll accurately, get it right. So it's okay. And you should also mention, no, chunks are different. Chunks are different. Okay. Chunks will not have that NASA because it's a different illustration, right? Which is not needed. Tables contain instruction. Can you see this is how the heading is? Symbols and abbreviations. Yeah, copy this. We'll do this next. We'll control this next. This is image 3. No, that's image 3 meaning it's a relevant image. This one controller, it's highly accurate. Controller interfaces, that's blocked, but yeah, it's again makes sense. Second image, that is also very okay. We got it. Oops, we saw this worked. Second is digital computer, that is also there. See, we missed this figure to simplify redundancy diagram. I think we'll quickly add it. Also, I want to extract above 250 chunks and below 250 chunks of each image. So along with the image, I also need to send the manual chunks. Are we already sending it? Because even though we have padding, there's a good chance we might still miss some figure information because we can't be sure the relevant context or text will be part of the image. So check the code. If not, please add it. I think it's possible. It's not a big deal. Anyway, you're getting the chunks. I just have to get the above and below. There's no point like assuming this will work or jumping fast from this, because if you get this wrong, then the entire pipeline will, like, you'll afterwards, like after you go this, will probably lose like focus on what we did on this and etc. And then later for us to find an issue, if something goes wrong, it'll be a nightmare. I mean, that we'll anyway come and do it, but right now you just make this as solid as possible. All the known stuff you should take care, and then hopefully once it is changed, it will definitely have like issues, then we come back and check it. So that's what I'm always trying to fix this, like try to make this as solid, make it as solid as possible, and then move to the next one. But still, mm, what it's trying to do is that it's trying to take all the text content and make it into a page, and then use that bounding box to access that specific text. That's okay, we can do it. The fourth image, No, this is wrong. It's trying to add it to tables. I only need 300 chunks above the image and below the image. I don't need to add it for formulas or anything else. Just I want you to make this change for pictures only and figures or figures or pictures. This is figure 5. Yeah, regulators, correct. Yeah, this is accurately captured, but figure 5 is not captured. See, this text is not captured. Yeah, that's what I think. Those content should be there. Oh, maybe I think yeah, the process is happening. They're already sending, so we have to check. I'm actually checking incorrectly. I have to check the chunks. So I can check this image, figure 5, page 16 image, figure 5, page 16 image. This is different. Oh, this is different. This is figure 6. for this, if I go to this image here, if I open JSON, figure 6, and own in figure 5, each memory model consists 4 boards and a word of electronic boards in connected. Actually, this 6 image path is just output figure 6, 17. Context above, okay, above. Sure. And context below is figure 5. Okay, okay. Let's check figure 6 here. And yes, it's right. So figure 6 memory half stack module, even though this image doesn't have that data, half stack module, you can see the figure illustrates the memory half stack module showing its internal structure. It consists of 4 memory modes stacked vertically, each connected to a word of electronics port on the right side. These components are, you can read this up, it's very accurate. Right, key elements, memory boards, what I can't spell that, but figure is diagram, and then image output is just, you can literally see it. It doesn't have anything else, but the text is very good because you have the up and down information. Is technically relevant, true. Yeah, okay. Okay, now what I want to do is that I think if this is also okay, table is also okay. You can, table is okay. It's part of the same chunk. If there is no symbols, it's wrong. So we'll solve symbols quickly. Actually, there seems to be symbols in the document, and this is what I saw. This was actually was part of the heading of a chunk, so I realized there's actually symbols and abbreviations. So I'm sure because these are scanned copies, you will have extra spaces and etc. We have to use regex, or we have to do semantic search. Can you pull this off using regex, using keyword search? Will that work? If not, we have to rely on semantic search. That's the most accurate way. We have to get it right. Symbols are very, like, 100% important for this. So check and let me know. Because some would say abbreviations, some would say variables, some would say symbols, and etc. I think semantic search would be the best, but if then we should have embeddings and all. Uh, at this stage, could you pull this off using regex? Because right now you have extra 5 spaces, 10 spaces, but what if it differs? If it's abbreviations first with a lot of space and then symbols? Just be honest. If regex would not work for it, we'll tackle this once we have the embedding model. Yeah, that's a reality. There's no point if that's if projects can't handle it, and if this would change, that's one of the reasons why when we do semantic search in the first place. So we can tackle that during when we work on which is next. I'm planning to use OpenAI embeddings, or there's an open source. I use both. I just want to improvise on it. Like, I don't have a clean structure that I want to follow here. I just want to try something new and see something. I was going through some embedding models. I think we'll just stick with OpenAI embedding for now. Not a big deal. Um, or maybe what we'll do is that we are gonna anyway use a GPU, right? We're gonna process 10,000 docs, and we'll probably use like an open source embedding because you can use a GPU, and then you can literally can we do then just managing GPUs and stuff. Um, yeah, we'll use an open source embedding model, and we'll just use something. Not a big deal. Because everything is text here, right? And there's some abbreviations that will solve them through domain terminologies later. But for now, then we can use some decent open source embedding models and use the same GPU to do the processing as well. So that's cheaper. We need to pay OpenAI, and yeah, we'll do that. So you're right to question this. Be honest, OCR symbols, these are symbols, space is different. I guess simply normalize the text by removing all spaces, then search. Hmm. No, for example, even though the result is symbols and abbreviations, no question. So even if you do a white space normalization, what if it's only abbreviation, or what if it's abbreviations and symbols, or what if it's something else? Yeah, yeah. It's fine. You add this as a to do in our development plan document, and we will check back when we use embedding models. Okay, so we'll work on this later. Actually, it was my issue with testing. We might not need this, so revoke this, please. Or your recent change on this. Only for pictures is more than enough. And it was already working, it was my issue. Okay, that's enough. Alright. Alright, now next I want to work on quadrant and save these chunks to quadrant. But before that, I want to have one final chunk. So, current before even that, I want to know this all chunks, this the chunks have the tables, formulas, everything, but also in order. Do they have everything in order? Also, I see a lot of what do you call? I see a lot of metadata, key elements, figure type for images, and then for tables, I see a lot of stuff, and then I also see for formulas and etc. Are this going to be as part of metadata for the chunks as well, for those specific chunks? Please check and let me know. Do not code yet. All right, so I did something similar recently. I'm just checking through that. So chunks contains the problem results are not in chunks. Tables, formulas are separately stored. The Venus is on chunks. This has to be in chunks. Formulas have to be in chunks. Okay, through chunks. Yeah, so it's something similar. Yeah, so I think when I did something similar before for one of the projects, and I'm just not projects, but it's sort of like a POC sort of thing. Just going through that, I think um how we even did this was you can't do it through pages. Because I totally forgot. You can't do it with pages, but what we did was that we n- dockling when dockling so we'll when dockling this past a PDF, it has its own order. I can check one of the codes, I guess. Yeah, so we'll check docklings docs. When dockling passes a PDF, it it provides some positioning or something. It was called something. Just a minute, I have some code here. Okay, over here. Yeah, okay. So checking docs, and I basically want to check this yield items in reading order. So what we can basically do is that we can use these um, items and save it, later process it, and then get those information, come back and store it. So you'll still have the reading order. Um, yeah, that should work. I did something similar as well. That's But I just want to try this different. You can still do it through bounding boxes. Last time when I was working, I did it through bounding boxes. You could also do with iterate items, the yield items as well. But yeah, let let Claude check it and let me know what would be the best process for this. Yeah, it gives us all the text tables, pictures, and reading order with hierarchy levels. Of course, that's what we want to do. Let's go with this. Why is it going picture description? What are you even trying to do? We just need we, what I really maybe what are you even trying? What are you? So basically, what I want is that I want you to uh, currently I want to have final chunks, and the final chunk should have all the I mean, I have to have the document in order, and then we would also need to have the sub processes we run, for example, tables, symbols, figures, and all of them. And that should be all the extracted descriptions. Whatever we do, we get the answer from the response from the VLM, and we store it in order. So the thing is, there's already, you probably will have access to the order, because anyway it's um, you're using docklinks model, and then you necessarily have to, you know, track, just put back whatever comes, put back whatever the response you get from the VLM in backend order. That's what you have to simply do. There's no reason you want to check pixel description, etc. I'm gonna also paste some code that I already did work on. So essentially, so this is one of the things that I did recently, was basically using it. I don't know why it's not able to find it, but what you can really do is that you can get the reading order, because it already captures it, right? And you use to VLM. That's what we're essentially doing. The order is already there. It's just messing around. So I just had to paste it. And I basically have a lot of like templates like this. Basically, have a repo of stuff that I've already done, and I sort of ask questions based off it and just get inspiration, because I tend to forget. For example, let's say even if you solve it, you'll easily forget what you know how you solved a specific approach and etc. So I tend to save it, or just query it back and get it from Claude. Yeah. No, so this time this should be easy as well. So once it's done, we can verify. Sorry to interrupt, but the VLM. Uh, So you're not basing this on just a page, right? You're also using order number or something like that, right? In a given page, because you can have multiple images, text, and everything on a single page. You're using order from order number or order ID or something like that from the layout detection model, right? I don't think I want to overkill and bring a lot of errors as well, guys, because we're also doing like we're detecting missed documents and etc. Let's do this. Actually, it's fine. I don't want to overkill this as well. Um, the current approach sort of works, but how easy? What is an easy approach that you can probably you have access to bounding boxes, right? Could you use a location in order to identify where the where the picture originally could have been or could and try because we already do this sort of sorting in missed documents, right? Missed tables as well. So I don't think it'll probably be easy for us to do the same sort of thing, take an approach here which is less complex and also does the job. Because I don't want to update the code and sort of get into a huge fuss. I think because we're processing a lot of what do you call um, we're doing a lot of what do you call we're doing a lot of custom stuff as well. So for example, like we're doing like finding missing which are images alone, then you wouldn't keep track of the page item and etc. So that's what I'm saying. I want to do something simple and use maybe bounding boxes are the most, and still we are not recreating a PDF, right? We're just having JSON. As long as you have the order, it should be right. Yeah, exactly. That's more than enough. Same look and high accuracy. Same, you basically get the same thing. Yeah, I saw this before. Build VM, it's just not needed at all. All right, so this pipeline basically provides a final chunk in order, including tables, which has its markdown and whatever metadata the tables provide, images along with what are the what like figure type, key elements, whatever the image output response is, apart from the description, which will be chunked, and the other ones will be stored as metadata, and the formulas as well, right? Just confirm this. I think so. Let's see. We want to have formulas, the formulas in order as well. But the question is, do you need formulas in now, thing is because we're taking it as a full page, right? So then we can't actually. What we can do, yeah, the thing is like this, we don't want to spend much time as well because for the LLM, it doesn't matter. Anyway, it's not reading the entire page. Even if it reads, it's totally okay. For example, if I go to this formula, if I go up, of course, there'll be a small minor, it's not as like humans reading it. But yeah, anyway, humans are not reading it, right? So we don't care. Reading it meaning like at the end, like they're not like they'll see it in the NLP search and pull it up, but when we go through the embedding search, it like we wouldn't see it. But the thing is, you can see residence time. It's assumed you can see that. Like, see, the particle then leaves the surface when the binder has regressed beyond the additive. That is when T is equals to Y over M. Now, if this is if that is when, and if you replace this with something else, it'll be very inaccurate. So now I actually plan to chunk this. For example, if it's from page 5, then we'll have after actually all the page type chunks are done, we'll probably have one final chunk that has all the formulas on a single page. Right now, the thing is, just check this document. Basically, you would want the formula to be right after, like it needs to manage have context. You can see the formulas, they describe something, and then the formula comes up. Like you can't, like if that formula gets messed up, it's a lot of incorrect information. Like you can't validate the formula, you can't like you can't arithmetically perform operations or do some tests, validate it and come back, right? You just assume the LLM just assumes that's the right thing. It doesn't validate whether the formula is right or not or makes sense. It's just gonna pull it because it's probably gonna read that like 20 30 documents. It's not gonna validate all the formula. So then I think we have to solve this in a different way. What are your creative thoughts? I have some. One of my idea here is that what we can do is that um mm, yeah, so what we basically can do is that you I mean we have the formulas, right? What we can do is that we can try to, if there's text above and text below, what we can basically prompt the LLM agent to get the first four chunks or whatever, then no, just four chunks, maybe like first 5 or 6 words, only words, and then the last 5 or 6 words, and then we can use some rejects, or maybe just and you should also understand that these documents will have a lot of spaces. We know that it will have it's not sequential. You'll have like double spaces in between like 3 letter words and etc. So what you have to do is to merge everything, remove all the spaces, and then try to match it, because we exactly know what the above four and below could be. You can easily target what easily target. I hope you can easily target. It should be same. It should be the same for each and every. What do you call it? It should be the same for each and every formula. But there's a lot of issues here as well. What if you have three formulas in a go? If you don't have any text in between, or if you don't have anything in between, that's a huge problem to solve. So think on this. There should be some way. Docklink should provide us with something, or there could be some so could be some solution. So check it, let me know. Okay, guys. So to pause the stream in 15 minutes, I'll probably come back and continue. Yeah, but the thing is like that. The reason why we did not even why we didn't even use formula is that the detection of formulas was very incorrect. Let's say in a page you have five formulas. Dockling only captured three or four formulas, and some of them were only half formulas. And that's one of the reasons why even we sort of what what did we do? We basically sent it to the VLM and processed it, like the entire page. Let me know if you have any other ideas. But I think what we can do is that because anyway we're sending the full page, we can prompt the because it's I mean this has to be accurate, right? I know it's inefficient, but we have to do it. What we can mention is that you probably want to return, like we want it to return the text, the formula, and the text and the formula or formula file, whatever, in proper order for that specific page. Because if there's a formula in page 5, we will send the page 5 and let LLM process the entire page 5. Let it return the entire chunks for the page 5, not chunks, basically the text and the formula and whatever whatnot. And then using that, we don't need to chunk that specific page, or let docklink chunk it. We'll just override it with our chunks, and we have the chunks. We can probably backtrack and use those chunks because there's a gap, right? 500 chunks or something like that. What we can do is to get the text, and if the what do you call if the previous chunks are not if the previous chunks are less in value or something like that, we can add them, or just keep it simple. Just use our chunking and just process the chunks, the page file chunks hybridly. Like we'll just chunk them and chunk the entire page file. And yeah, it's okay if it's like there's 200 chunks more, 200 chunks less. It's not a big deal, to be honest. Give me your thoughts. What are the concept is? Don't worry about the API stuff and all. We might run this locally, so it's basically like a couple of minutes extra work. That's it. I will actually implement this guy's growth here. Accuracy. So still we. So thing is, you can't get everything right. You can't do it in a way that everything So where you like with less amount of API calls, high quality work is very impossible. And yeah, what I could basically say is that we're just trying to work with. We're just trying to weigh the options. Formulas, you can't miss formulas. It should be accurate. And because dockling passing work does not work properly. I'm sure other models passing were all. I don't want to take that sort of risk. So because of that, I'm prioritizing accuracy over efficiency and trying to do this right. So, but yeah, it's not the best solution. But also, if you take this particular page and, for example, see this entire page, right? This is one page where there's a lot of formulas: one, two, three, four, five, six pages. So you have 30 pages and six of them would be processed by a VLM. That's still high because you're again processing images through VLM. You're also processing a graphs through VLM. You're processing symbols through VLM. But the thing is, like, that's why we have a VLM in the first place. So don't worry about tokens and etc. Just spend it. We need accuracy. And plus, we are running it locally, so it's okay. Because at this point, I can't think of a, and it'll definitely slow down a lot because of the chunks in the algorithm. I can't think of a way we get. Oh, let me see if I can think something. Only thing that we can do is to, what do you call, yeah, this is very accurate. Like we have to have it very accurate here, guys. So if we got good layout detection for formulas like what we got before, then it's very simple for us. But here we can't afford to lose anything. Plus, even if I think, let's say we put this um uh put this as an like connected page above, still it won't be right. You can't. I'm thinking if you can have some placeholders here instead of the formulas. You chunk it, have placeholders, and once you have, and I have an ID for the placeholder, and then when you have, once you got the processing, you just replace each placeholder with that ID, whatever the formula you have. But still, in order to detect it, like for you to really detect, like there's some sort of formula going on, like the general passing will not work, and that will still fail, and you'll end up in a bad spot. So yeah, yeah, it's gonna definitely increase the. Yeah, but still, this is one. But if I were to take this PDF, just see there's no you don't see a lot of formulas there, right? Like these are diagrams a lot. See this page, in this page, this is 19th page. You see the first formula, second one, third one, and just three pages in a 30 page doc. And yeah, just prioritizing accuracy over here. And this doesn't have formula. So yeah, and this has a lot of formulas. This is filled with formulas. One, two, three, four, five, six, seven. Yeah, yeah, 7 pages faster. Let's actually continue this guys in the evening. So I'm gonna pause the screen. stream and come back in the evening and continue on this. Thank you so much. Bye. And I probably will, if this is a worst case scenario, sort of work here. I don't want to do it because it'll take a lot of time. The thing is, you can just parallelly run everything, and maximum take 1 to 2 minutes. If you parallelly run even 10, parallelly doesn't, each request might take a minute. But if this is the only option we have, we'll actually run it. Okay, but I'm gonna just click on yes. This is the worst case scenario. Let's still implement it and just keep it. And yeah, if I'll probably think of some other ways. If we have something else, we can come back and change it. All right, see you in the next one.